All right, we should be live. Just gotta finish getting things set up. Okay, so... All right, we should be good to go. All right, great. Hopefully everybody can hear me clearly. Here before the theists, here before the creationists. Today we're talking to creationists, not theists. At least that's the hope, but you know, we'll see if we get any bites. If we don't get any bites, then we don't get any bites. YouTube is A-okay. I'm glad to hear it. I think I've gotten this down to a science at this point. I'd like to think. Yeah, we did just start. Make myself a little bit bigger even still. There we go. Are you at home or in the lab? I work from home. I'm not an experimentalist. I don't do experiments. Those people are very talented and not me. Early churches invented modern science. Churches didn't. Christians did, at least to an extent. Arguably, science started with the Arabic Golden Age. No horizontal stream? There's a horizontal stream. You just have to go to the right YouTube account. All right, let's talk to 69 Ching Ching.
Hello, mate. Yeah,
hey,
it's a weird
how's it
name.
going?
I just have a question for you.
Okay.
What was the hardest thing you faced in your PhD?
This is not the day to ask that question.
Oh, what's the question?
Wrong live stream. Let's talk to Midwest Spaceman. Midwest Spaceman, how's it going? Oh, and he's gone. Yeah, look, I mean, like, I don't really understand why someone would join a live with chat is tiny. What do you mean chat is tiny? I don't know what that means. I don't know that text is smaller. Is it? Okay. Yeah, okay, I guess it looks normal. Okay. Yeah, somebody said I should debate Darth Dawkins. I have before. He doesn't come on my live streams anymore. All right, let's talk to Orielco. I feel like I've spoken to Orielco before. Orielco, have we spoken before?
Yes, we have.
Did we talk about this topic?
Yes, I kind of.
Okay. Well, here's a question. How old do you think the Earth is?
6,000 light years old.
That's
Whatever
not an age, that's a distance.
So not light year, right? But light years old.
That's a distance, not an age.
So that's what I wanted to talk to you about, right? So let's say with Einstein's equation that you do reach the speed of light exactly.
You can?
Right? Yes, right. So then you do age at a certain pace.
Well, no, but you can't go the speed of light.
But let's say we did, theoretically, right?
So theoretically, let's just break the laws of physics. Mathematically, you can't. It doesn't make sense mathematically.
We can't. Mathematically, yes, we can.
No, you can't.
so infinity, right? So infinity can be taken out of infinity itself, right? Without affecting the infinity. That's true.
I have no idea what that
Yes
means.
or no?
Look, mathematically, if you were to go to the speed of light, you'd be dividing by 0. And you can't do that. You can't divide by 0 mathematically. So you can't go the speed of light.
So let's say if I take a number out of infinite numbers, what number am I losing? No number, right? Technically.
Sorry, what? If you take a number out of infinite numbers?
Yes.
So if you have like an infinite set of numbers and then you remove one of the numbers from it, you still have an infinite set of numbers, yeah.
Yes. Right. So let's say if I take out infinite numbers out of those, how many numbers
it depends on which set you remove. You could remove the entire set, in which case you'd be left with nothing. You could remove the entire set except one, in which case you'd be left with a finite number. Or you could remove an infinite set that still leaves an infinite set behind.
Yes, set theory, right?
Yeah. What does this have to do with the age of the Earth?
So now the age of the Earth, right? So you say like 6,000 light years old, right? So
but that's not an age. That's a distance. A light year is a distance. It's like, what, like 4 or like 3 trillion miles or something, if I remember correctly? I can never remember.
Yeah, I mean, light year is a distance, but what I'm trying to say is that what is the
6 trillion.
Universal time frame of Einstein equation if we do reach the speed of light, right?
You can't reach the speed of light.
So at what time frame is our body clock running on then? If we do reach
so we have something called proper time. Our proper time runs at, well, it runs at 1 second per second. Now, relative to somebody else's proper time, our proper time might be faster or slower. If somebody was floating out in deep space, but otherwise not moving relative to us, then their proper time would tick ever so slightly faster than our proper time would.
And what is that proper time based on?
Based off of like what your wristwatch does. So their wristwatch would tick ever so slightly faster than our wristwatch.
So when you say like 6,000 years old, right, you base it off of the how many times the Earth has gone around the sun, right? But then again, when we look at like, hey, how much time the Earth has gone around the sun, that is how, not exactly what we started measuring, right? We used to measure like, hey, how many times the moon has gone around the Earth, because we were geocentric at one point, right?
We've always measured a year by how long it takes for the Earth to go around the sun. Now, it turns out that
was Roman calendar.
It turns out that 3,000 years ago, or 2,000 years ago, or 1,000 years ago even, they misunderstood what it was they were measuring. They thought they were measuring how long it takes for the sun to go around the Earth and come back to where it started. That's what they called a year. But that is what they were actually measuring, is how long it takes for the Earth to go all the way around the sun. Put another way, they were asking how long does it take for the seasons to cycle again.
Yes, and you could follow the moon calendar and you could relatively arrive to the same thing, but you defined 1 year old as, hey, we go around the sun in these many things, right? These many days, right? Or in 4 seasons, and we'll call that a year, right? Yeah. Is that yes or no?
Yeah. Roughly a year is the number of seasons divided by 4.
Yeah, right. So then we are assuming that that's how but we go with human calendars, right? Then we can see that Earth is only we only started doing that 2,000 years ago, right?
Well, sure. I mean, it just depends on which community you're looking at, but sure, humans have only been keeping track of time for a few thousand years.
So now, if we go a little further back, then we can see like moon calendar, right? And before that, anything can be programmed.
As long as we've been keeping track of the moon to indicate the month, we've been keeping track of the year. But we don't have records of humans keeping track of the years from more than 6,000 or 7,000 years ago.
Yeah, but we don't have people keeping track of moon calendar either, right?
Right, that's my point. But that doesn't mean that those years didn't happen.
Yes. So now we are questioning history, right? Because we know that since 2000 years ago, we have been tracking solar calendar, right? Or the position of the sun, right? And
to be clear, that predates 2000 years ago, but sure.
Relatively, right? So now we don't have much of the history that we're arguing about, right? Even you and me right now.
Do you mean like the human history, or what kind of history?
You're saying like billions of years old, right?
So what kind of history are you thinking about here? Because we absolutely do have like what you might call like geological history, right? Like we can go and we can look at when, you know, XYZ volcano erupted 5 million years ago, or when a meteor hit the Earth however many whatever years ago, or that the glaciers retreated 12,000 years. Like we do have that history. Now we don't have a human history because humans weren't really keeping track of what we were doing at the time.
Yes. So, and all of those, right, that we can get from the data that we get from the environment, right? All of those data, I mean, isn't it pre-programmed? Like, couldn't it be pre-programmed?
Could all of your memories be pre-programmed too?
Right now, yes, but like before I was born, maybe. After I was born, no.
Why not? Why couldn't they have been pre-programmed after you were born?
Because your interest lies in different place than mine. Because I don't know what you value more, right?
What? Look, all I'm asking is, how do you know that last week existed?
Because I'm going by my own programming.
So could your memories prior to last week be completely fabricated and just pre-programmed into your brain?
Yes, it could be.
Okay. But do you believe that?
No.
Okay. Why not?
And why would they do that?
Well, I don't need to give you a justification.
Yeah, I mean, like, why would they do that, right? So
who they? I mean, maybe the universe just popped into existence like 2 days ago, and you popped into existence with all of your memories.
And why would I care?
Well, the point is whether or not it's true.
Yeah, but it's untrue, right?
Well, that's the question. Why do you think that it's not true?
Because I have history, right? So
but how do you know the history wasn't pre-programmed?
Before that,
how do you know the history wasn't pre-programmed?
So I'm programming, right? As long as I have programmed it, I can be self-assured. Unless someone like you says it, right? Hey, how do you know, right? You have not been programmed. Then obviously, like I'll not question myself, but I'll question you, right?
No, you should question yourself.
No, I'll not question myself. I'll question you.
Wait, why wouldn't you question yourself? How do you know that your memories are correct?
I mean, like, I don't base anything off of my memory, right? I base it off of certainty. So I don't like what you're talking about here.
How do you come to certainty about, last week happening?
Because I don't care if last week happened.
Really? You care?
Yes.
So you don't care if last week happened, but you do care.
I don't even care if yesterday happened.
So you understand what I'm doing, right?
Yes, but what I'm trying to say is that, yes, the Earth is, you're trying to see, like, hey, history from a certain perspective, right? And you're trying to say, hey, so now I'm basing it off of, like, hey, I don't care about what happened yesterday, right? And I don't want to verify, right? But I would love to care if Earth is actually 6,000 years old, right? And your 6,000 years old is based off of solar calendar, which we only started tracking since 2,000 years old. So I'm not sure like where you're getting this data 6,000 years old from, because...
Let me explain then. Because, look, you asked if all of that evidence that we use to come to the conclusion about when glaciation events happened, when meteors struck, when volcanoes erupted, all of that data, if that could have been pre-programmed into the Earth, so that the Earth really isn't 6,000, or really isn't billions of years old, but rather it just looks like it's billions of years old because whoever made the Earth pre-programmed it that way. That's what you were asking. Now, using that same line of reasoning, namely, well, how can we say that historical evidence implies that the history actually happened? We can come to a very, very similar conclusion, or a very, very similar level of skepticism, that about whether or not last week happened, whether or not Jesus ever existed, whether or not JFK was ever assassinated, whether or not any of these things ever happened, just by saying, well, we live now. How can we trust all of the historical evidence, all of the memories, all of the video of these things happening? Maybe whoever created the world created it last week and just made it look as if it's far older. The moment you start questioning all of the historical evidence that we have, you end up at last Thursdayism.
Not questioning history, right?
Geological history is just as much history as written history is.
So geological history, what does it? So that's geological history is based off of carbon dating. Carbon is based off of.
It's not based on carbon dating.
What is it based off of then?
It's based off of a whole slew of methods, but carbon dating doesn't really get you into geological time. Carbon dating gets you to maybe 50,000 years ago, and geological time is far, far, far longer.
So what is geological timing? How is it measured?
We can use things like uranium-lead dating. We can use things like cosmogenic nuclide dating. We can use things like ice core dating.
That's half-life, right, basically?
Which one?
Uranium, everything.
No, only the first one was. Only uranium-lead dating relies on half-lives.
What do the other relies on?
So cosmological radionuclide dating is based off of the deposition rate from space of certain rare isotopes in revealed Earth. So like you have a glacier that retreats, and as it retreats, it reveals more like stones and rocks and stuff. And because the glacier is no longer covering those rocks are now exposed to cosmic rays, which then cause the atoms in those rocks to change. And you can basically count how many of those atoms have changed, and that will give you a measure of how long it's been exposed. Then there's ice core dating, which essentially just counts how many seasons have happened, because you can keep track of the seasonal changes in the ice deposition in places like Greenland. You'll see cycles repeating over and over and over again, that when you'll get more you'll get a different kind of ice in the winter than you will in the summer, and so you can see how many layers there are. There's tons of different and independent ways of measuring the age of the Earth or measuring geological time, and not all of them rely on radiometric dating.
So season change, that means the change in event, right?
I don't know what you mean by change in event.
So when you say season change, that means the rotational of the Earth changes, or the...
No, what I mean is that over the course of a year, you have summer, winter, or you have summer, fall, winter, spring. And so because of temperature fluctuations, because of atmospheric fluctuations over the course of a year, the kinds of gases that's present, the kind of ice that's present in these ice cores fluctuates in a periodic way.
Okay. Yeah, seasonal change, and then basically the formation of rock, or the growing of tree, right? With how many layers of the trees around it has, or how many layers of rock it forms, then you can trace the rock to its origin. Isn't that basically it?
Well, yeah. That's another thing that you can do. You can also look at like sediment deposition rates. One of the other ones that I mentioned was cosmogenic radionuclide dating, which relies on relatively consistent rates at which cosmic rays strike the Earth and deposit different amounts, or deposit fairly consistent amounts of new materials into rocks, and it changes the makeup of the rocks. And we can look at the makeup of the rocks and check the amount of these new atoms that appear. Like there's like half a dozen different ways that we can figure out the age of the Earth, or figure out rather that we live in a very old Earth.
So what you're saying is that depending on if the Earth was static, right, and if Earth was not static and it revolved around the sun and exactly and as it was, then it would see the formation of rock would be as it stands now, right? Is that what you're saying?
Look, so if the Earth was only 6,000 years old, then there wouldn't be enough time to deposit these certain atoms into the rocks that have been exposed by glaciers, because it takes time for those atoms to be deposited into the rocks. And we see more of those atoms than could be accounted for with the 6,000-year-old age.
Okay. That makes sense.
So, I mean, like, look, this is the same kind of, arguably, this is better evidence than like just having somebody's writings, because writings are subjective, right? What we're talking about here is objective hard facts. It is true that we have ice core samples. It is true that we have uranium-lead dating of zircon that leads to very, very old ages. It is true that we have cosmological radionuclide dating. All of these things are objective, whereas the history that we have is subjective. And yet, for some reason, it seems like you're reliant on the subjective reading of history from a few thousand years ago, and you trust that, but you don't trust the objective history derived from the scientific process.
So I do trust it, right? But the question is, like, if you keep digging, you'll find something, right? And science is basically the same way. 6,000 years old, 6 billion years old. So the history of Earth itself, right? The universe is 13.6, right?
13.8 or so, yeah.
Yeah. So, and if we go biblically, then it says that, hey, we are on seventh day, right?
No, that's not what it says biblically. The seventh day was when God rested, and then other stuff happened afterwards.
Which is what's happening right now, right?
Yeah, that's after the seventh day. So biblically, we're like 6,000 years in, not like 7 days in.
Yes. So, and the history of universe itself goes to 13.8 billion years old, right?
Yeah.
And that's technically, if you divide it by 2, right? Then you get
hold on. 7? Before we pivot into like some numerology stuff, what do you make of the fact that we have this objective evidence that the Earth is older than 6,000 years old?
So the whole age of the universe itself, because we kept digging besides more than Earth, right? And 2,000 years ago, what happened was that they wanted to dig even further, and someone had to make up something, right?
I don't know what you mean by digging.
Once you keep digging, so let's say once you start digging wherever you are, right? What happens if you keep digging?
Digging what? Like in the ground?
A hole. Yes, in the hole.
The hole gets deeper.
And eventually you reach the other side of the Earth, right?
Only if you think the Earth isn't flat.
So yeah, but then that's what happens, and you'll have a.
What does that have to do with anything?
So, eventually, why have we not been able to do that yet? Drill a hole.
Why haven't we been able to drill a hole through the Earth? What does this have to do with the age of the Earth?
Because something we have not been able to do, right? Because
what does that have to do with the age of the Earth?
Because what I'm saying is that if you keep digging, right, you'll find something, and age of the Earth the same way, right? Because we have reached a certain point where we cannot. Yeah, so the age of the Earth, right? It can be made up because we have reached a point where we cannot make sense of our data.
We
right?
can make sense of our data, though.
Increase that to billions of years of old.
We absolutely can make sense of our data, though. All of the data that we have is consistent.
I mean, like it's only consistent if it's only 13 billion years. 13.
Well, we're talking about the age of the Earth. The Earth is 4.5 billion years old or so.
I mean, like, so what is the age of the United States?
250 years old, almost to the.
That's made up stuff, right? We have to go dig towards the land, right? So what is the age of the United States land itself?
That's not what you asked. The United States is a governmental organization. You asked how old it is. I gave you the answer.
So you see, right? So many things that humans just make up, and
Look, the age of the Earth is not something humans make up. The question is, how many times has the Earth gone around the sun? That's a really simple, it's a really simple and super objective question, right?
How many times the Earth has gone around the sun?
Yeah.
Yeah, I mean, like according to the current scientific time frame, that's quite a few 4 billion years old, right?
Right. But you think it's less than that.
No, I think the whole universe is 6,000 years old. Like
right,
light,
which means
like
that the Earth must have gone around the sun less than 6,000 times. Right, because a year is the amount of time it takes for the Earth to go around the sun.
No, so what I think is that so let's start from just basic light, right? If we only have light...
Wait a minute, I really need clarification before we can move on. How many times do you think the Earth has gone around the sun?
4.5 billion times.
Okay, right. So the Earth has gone around the sun 4.5 billion times or so. Now, what do you call the length of time that it takes for the Earth to go around the sun?
How many times do you think an electron has gone around an atom?
Can you answer my question?
I don't care. You see, I don't care.
Okay, so I'll answer the question for you. We called that amount of time a year. Now...
Yes. How many times
So the Earth has done 4.5 billion things, each of which takes a year. Which means that the Earth is how many years old?
4.5 billion years old.
Right. And if the Earth is 4.5 billion years old, how can the universe, which contains the Earth, be 6,000 years old?
So that's the point, right? So if we base something off of a simple carbon itself, right, we can say like, hey, how many times the electron has gone around the nucleus, right? Really does not matter, right? Because now we have got a better point, right? Which is, let's say, what does carbon make, right? Maybe diamond, right? So now diamond can trap a light and they can base it off of that, right? Hey, we have a light and now we have, let's just say like Planck's, all the data of Planck's, right? And we can base it off of, hey, this is the time of light, absolute light.
What does this have to do with the age of the universe and the age of the Earth?
So when we calculate that, I think the light will have only traveled for 6,000 years old, right?
The light has only traveled for 6,000 years is what you think?
Yes.
Okay, which light?
Every photon, right?
Photons have only traveled for 6,000 years in your view?
Yes.
Okay, so what were the photons doing 4.5 billion years ago?
So I think they were in heaven.
Was the Earth in heaven?
No.
Was the sun in heaven?
I mean, yes. You could say that, yes.
So the Earth existed 4.5 billion years ago, but the sun didn't exist 4.5 billion years ago.
The sun existed, Earth didn't. Yeah, you could go both ways, right? So who came first, right?
I don't know how you can go both ways.
So let me preface, right? When I say Indiana, I'm from Indiana, USA, right? Which came first? Indiana came first or USA came first?
I'm pretty sure the US came first.
Texas, in some cases, Texas came first and United States, right?
No, I think it's still true that the United States came first.
Texas came first before the United States. Yes.
I don't. Well,
Texas
okay, maybe that's true. But like, look,
Florida
it is true that the sun existed before the Earth.
So, the same problem with Florida before United States, right? But nobody agrees, but we know, right?
Wait, but we do agree that the sun came before the Earth, right?
I mean, we both depend on each other, right? Because we depend on photosynthesis.
How does that answer my question?
Because it's kind of like, hey, do you depend on your mother or your dad?
I didn't say depend on both. And I wasn't asking about you. I was asking about the sun and the Earth.
Yes, one is dad, one is mom, right? Would you depend on? I depend on both.
I'm not asking about what depends on what. I'm asking which one existed first, the sun or the Earth?
Moon existed first.
The moon existed before the sun.
Yes,
in your view.
all of them.
What?
Moon existed before sun.
Why
and
would
the
you
Earth.
think that?
Because that's what we based it off our calendar on, right? Moon gave birth to our solar calendar.
Who cares? What does the calendar have to do with anything?
Because we go by our own time.
Look, okay, wind the clock back so that Earth was just about to start its first orbit around the sun. Did the moon exist?
Moon existed before everything else. Start everything with moon. Do not start with Earth.
How did the moon predate the sun and the Earth?
I don't know. Create one right now. It'll make more sense now.
What?
So, moon came into existence before Earth and sun.
Why do you think that?
And why do you not think that at all?
Because we know how the Earth formed, we know how the moon formed, we know how the sun formed. In order for the Earth to form, the sun needed to exist.
How did moon form? Tell me, how did moon form?
A collision with a protoplanet called Theia and proto-Earth. Knocked a big chunk of stone out from of molten rock out from the proto-Earth, and then it coalesced into a moon that now orbits us.
So you've never been to the moon, right? And nobody besides Neil Armstrong has been to the moon. We don't have any data on the moon, and you're claiming we know the moon, right?
I'm gonna crash out. Nobody's been to the moon besides Neil Armstrong. So you don't think the moon landing is a hoax, but you think that Neil Armstrong was the only one who went?
I mean, a couple of them, right? But
so to be clear, I think that there were 12 people who walked to the moon. We have moon rocks on Earth that they brought back. We have we have.
So just by bringing a rock, you know the whole history of the moon, and you
actually,
think that...
yeah, science is pretty impressive, isn't it?
Oh, so you think like we're not the moon people at all? I actually think that we were actually on moon, right? And then
are you trolling me?
Are you? So how do you know that we were never settled on moon first, right? And then we jumped to Earth?
This has got to be a troll. Has it just been the most elaborate troll I've ever seen?
Because you said like sun came or the Earth, right? And now the answer is like both of them came at the same time, and moon exists between those two, right? So moon came first. Now I'm arguing based off of your argument, because sun and the Earth, right? They're like mother and father, right? Because sun is like sun, right? Mom, and Earth is like mother Earth, so they have to have a pair, right? So the only one that begets both is moon. So moon comes first and then both. So there it is. I'm arguing based off of you.
No, you're not.
Yeah, because sun and Earth are paired, right? They have to come together.
No, the sun predates the Earth. The sun came. Nope, the sun existed before the Earth did.
Nope, they have to come together.
Why?
Not possible.
What? Why isn't it possible?
Try and create one. Like, that's what I'm asking, right? Why is it possible? And like, why is it possible for you?
Why is it possible for me to create the sun?
Yes. So how is it possible in your model to create...
that I can explain. So in standard cosmological models or standard astrophysical models, stars form, our sun is a star. Stars form via the coalescence of gas. Now, as that gas is coalescing, not all of it falls into the core, and so not all of it becomes part of the star. And rather, what you end up with is just a big gas cloud surrounding a star. And as the star continues to develop, that gas cloud, some of it continues to spiral in, some of it kind of gets ejected out, and eventually you end up with a protoplanetary disk. That protoplanetary disk then eventually coalesces into planets, and some of those planets collide. And in the case of our star, our Earth, the two planets collided, one that we now call Theia, and the other one was Proto-Earth. Theia collides into Proto-Earth, knocks out a big chunk, and we're left with the moon.
So that's the formation when you go by time, right?
What else are we doing?
So if you go by the creation of the universe itself, right, you have to create a timeline. And in that timeline, moon has to be created first before sun and the Earth.
Why does the moon have to be created first?
Because it's a separate entity, like a sphere entity that can exist by itself.
The sun can exist. The sun can exist by itself. The Earth could exist. They're all just spheres.
So, so what I'd suggest, right? Because if you start from scratch, building universe from scratch, you have to create moon first, and only then you can go to sun. And
what is happening?
Because a star does not explode, right? Unless it is filled with iron. Yes or
what? No? What star? Why do you need the moon? How did the moon get there?
How do you get a star to explode?
Our sun hasn't exploded.
But tell me, like, how does a star explode? What is the reason for a star to explode?
How is this relevant?
It's really relevant because that's when the creation of moon happens.
So you're saying the moon happened as a result of a supernova?
Yes.
Okay. Why do you think that that's how the moon formed?
So that's basically the position of electron, and so moon is outside of the Earth, right? So same as nucleus, right? Which has outside of it exists the electron, right? So same as the concept is, hey, Earth, inside is Earth, outside is moon, right? And the similar concept.
Why do you think that a supernova formed the moon?
Supernova is an explosion, right? Of
the type of explosion, sure.
Mm-hmm. So why does it? The reason it needs to explode comes in the topology.
This has got to be a troll. It's got to be a troll. I mean, I'm going to post it, and I'm going to pretend it's not a troll, but it's got to be a troll. Like, it has to be, right? Like, that's... Okay. All right. I'm going to read some super chats. That was crazy, by the way. All right. So from Sunapeak with the 25 AED, which I don't know what that is, but let's find out. Oh, those are United Arab Emirates dirham. It's about $7. Thank you, Sunapeak. Earth is 6,000 years old if you account for inflation. What? Do you mean like the funny kind of inflation that's sad and makes people poorer? From Garba Gaiman with the 5 Canuck bucks. Hooray, horizontal stream super chats. Absolutely true. Yeah, we got monetized. We're all good. Just make sure to watch the video so then we can keep it that way. From Orion Cooper with the $2. This guy made the Kessel run in under 12 parsecs. Don't do that. Don't do that. From Point with the 2 Canuck bucks. Common Dr. Blitz W. Thank you. We have $10 from Anthony Morgan. Keep blitzing the ignorant with knowledge. Maybe that will coalesce into something substantive in their empty heads. Physics for the win. Look, we do our best, okay? All right, let's bring on our next guest. Let's talk to Jordan. Jordan,
Hello.
How's it going?
Good, you?
I'm doing all right. How old do you think the Earth is?
I would say we're almost at 6,000.
And why so?
I mean, I guess ultimately, I don't know. I lost a lot of faith in science throughout my years. I find a lot of it, you know, like I spent a long time looking for like fulfillment in science and like actual deep wisdom, right? And like trying to understand how the world works. And I ultimately found it very disappointing. It left a bad taste in my mouth because science had been exalted as like, you know, it's everything. If you want to be smart, you got to be a scientist. The smartest people are physicists. And I wanted to be smart, right? But ultimately I was like, okay, none of these people really think deeply. And if they do, they don't even have a deep understanding. The deepest, you know, you guys are smashing particles together, but I mean, you can keep smashing for infinity. I mean, how deep does it go? Like your understanding is never really going to get that deep. You're going to unalive before you have any real understanding of how the universe works And then what? And then all of your sciences.
How do you?
And so anyway, so I spent all that time with science, and then I started reading the Bible instead, and I was like, this gives me hope for a future.
So when you talk about like deep understanding, you just mean like things that make you feel good?
No, I mean like I was literally studying physics, trying to understand how the universe functions, and ultimately.
And what did you learn?
You guys huh?
What did you learn?
Ultimately, you haven't gone that deep,
How do you quantify that? I mean, like, I would say that we definitely understand more, and we know more deeply how the universe works today than we did 150 years ago.
Yeah, but there's still so much that we don't know. I mean,
how do you know how much we don't know?
Because you can just go on Wikipedia and look at what the smallest particles are and how they function, and still nobody really knows. You guys just you put labels on stuff.
Let's say we go on Wikipedia and we look at what the smallest particle is. What do you think it'll say?
I don't know, it'll be like leptons, quarks, all those. You guys just put labels on a million different things that you've measured. I mean, I don't know.
So those are names of things. You asked for, or you suggested that we look up what the smallest particles are, and then you came up with a list of names of what the smallest particles are. So I don't see what the question is. Where's the issue?
But you don't really understand. It's not very deep. It's still very shallow understanding, because those particles could be made up of other things that we don't understand yet. I mean,
you're speculating. Like, maybe that is the case, but maybe not. So,
exactly. You don't know, right?
Wait a minute.
No
so
idea.
How do you know that the understanding's not deep? It could be that this is the end, and that we actually understand everything.
Oh yeah.
Right. It's possible.
So I guess CERN should just stop everything.
I didn't say that.
We did it, guys.
What I'm saying is that, or rather, alternatively, maybe the next discovery is the last one. Maybe that's like the final piece of the puzzle, and then the whole story's done. You come on here saying like, oh, you don't really understand anything. You don't understand things deeply. You don't really know anything. You have no way of quantifying how much we know. You have no way of evaluating how much we actually know. It could be that we know 99% of it, or it could be that we know 1% of it, and you have no idea.
And neither do you.
But you're the one making the claim. You're the one making the claim that scientists don't know anything, that they don't have a deep understanding of everything.
Do you think you have a deep understanding of reality or not?
I think that depth is a relative measure. I think that our understanding of reality now is significantly deeper than it was 150 years ago.
But is it compared to the totality of all?
We have no idea what the totality is. Neither do you.
You have no idea. You have no idea if you're deep or not, really, right? It could be. You could
You're
be
the
deep,
one.
or you
look, I never made the claim that we have a super deep understanding of reality and we're almost at the bottom. You're the one who came in and made the claim that they don't have a deep understanding of reality. So can you back that up?
You don't think science broadly has the idea that they have a deep wisdom, that like, if you want to be smart, you go into science, because science claims to have all these deep insights about how the universe works. And I'm saying that claim, after investigation, doesn't seem very true to me, because it could go infinitely deeper.
So look, is your contention that like science promised you all of the answers and then you started getting into science and, oh look, you don't have all the answers? Is that your contention?
Yeah, I thought I would be learning like valuable, deep. Yeah, I thought I would have a deep understanding of reality.
Can you explain what you mean by deep understanding of reality? What do you mean by that?
I mean, getting close to a full understanding of how reality works would be.
And how do you evaluate how close you are to a full understanding?
Getting to the bottom of it.
Will you know that you're at the bottom until you're at the bottom?
No.
Okay,
that's the thing.
So are you telling me that, just to repeat what you said that science doesn't have a deep understanding of reality. But now it sounds like you're telling me that you actually don't know how deep of an understanding of reality science gives you.
And yeah, okay, but you're missing the point. The point is that, like, if it's possible, the fact that it's possible that it could be infinitely more deep, right? Just shows how far away you are. You could be, okay, you don't know. Maybe we could be right there. Okay, yeah, sure. Yeah, you really think that?
How do you know it's possible that it could be infinitely deep?
Almost there? Does it feel like you're almost there?
How do you know that it could be infinitely deep?
you're saying it's not? You disagree with that?
I'm asking, you made the statement that it could be. I'm asking, how do you know that it could be?
Oh, okay, sorry. Okay, so well, maybe I'm wrong. Do you think I'm wrong?
I think that you should back up your claims
disagree?
rather than just throwing things out willy-nilly.
Well, I mean, I think it could be. I mean, it could be infinite. There's a lot of things that
Like on
could,
what grounds?
Is it not? Okay, if you think I'm wrong, that's fine. You don't think it could be infinitely deeper? Do you?
I just want you to justify the claim that you made.
I don't. Maybe it's unjustifiable. I don't know.
So like you came in.
Why don't you give me an equation and figure it out?
So are you telling me
so
that
smart.
the reason why? So you studied science, which, you know, believable or not, you studied science, and then you had some thought with no justification to come to the conclusion that, oh well, you know, it could be that science is like not deep at all, therefore science must not actually be deep. Like it seems like you had some subjective vibes-based feeling. You impugned that on the entirety of the scientific method, the scientific community, etc. And then you use that to come to a conclusion that science actually doesn't know anything, even though the origins of that position stem from vibes.
I'm not saying science doesn't know anything. I'm saying what it does know isn't that impressive.
I don't know. I would say knowing how the Earth got here is pretty impressive. I would say knowing what knowing what antimatter is impressive.
Go ahead.
Sorry?
You know how the Earth got here. Yeah.
Yeah, it formed gravitationally in an accretion disk around a forming star.
Oh, really?
Uh-huh.
Yeah. What's the Earth? What's it made out of? Particles that you don't
made
just
of
a bunch
rocks.
of particles, right?
It's made of mostly iron.
And rocks are made of atoms, and atoms are made of quarks, and quarks are you have no idea. Woohoo!
We do know what quarks are. They're excitations of a field.
A field of what?
It's called the quark field. Top quark field, bottom quark field, down quark.
Tell me.
It's a fundamental thing.
Yeah, what is that? Because you're so deep. Your understanding is so deep. Tell us what a quark is.
That's the bottom.
Oh, the quark. How do you know that? That's a baseless claim. Back it up, please. Go ahead.
That's what the evidence points to.
And is that okay? Wait. So
that's how we do science. You come to a conclusion based on evidence.
What is the quark field again?
It's a fundamental thing. It's not made of anything, so we can't say that it's like made of something smaller.
Thing, guys. A quark is a thing. Everybody, yay!
I was in the middle of a sentence, but so the quark field is. I mean, you can describe it mathematically if you want. I don't know if that might be over your head. But the quark field is I mean, if you don't, do you understand what the word field means, or do you want me to explain what a field is?
A field of what? A quark?
Do you want me to explain what a field is? Do you know what a field is?
It's like a coordinate system, basically.
It's not really. It kind of lives on top of a coordinate system.
Coordinate system. Yeah.
It lives on top of a coordinate system, so it takes in
as
input.
It's something you made up in your mind. Yeah.
No. So I certainly didn't make it up. I think
it might accurately reflect reality, but you're not sure because you don't even know what a quark is.
Well, no, I mean a quark is an excitation of the quark field. Look, the point is that
what's the quark
I can give
field?
you answers. So Jordan, I can give you answers about things, and you could just keep asking why, and then sure, eventually you'll
didn't give me an answer. What's the quark field? You said it's a thing,
The quark field
bro.
is fundamental. That question supposes that it's made of something. But if it's not made of something, if it's truly fundamental,
it's something,
then
guys.
it's
everybody,
not.
The quark field is something. You heard it here first.
Jordan, look, the quark field is a field.
You have no idea
it has certain properties.
Just admit it, bro. This is
why
you're shallow.
We can perfectly well describe the quark field.
This is why you're shallow. This is as deep as you got.
Do you know what a field is?
As deep as your understanding goes. It's
do you know what a field is?
I just told you it's a coordinate system. It's a model that you made up in your mind. Yeah, that's what a field is.
Wait, so is your contention that the models and the reality are perhaps not the same thing?
How would you know? Why would I believe?
Why are you asking me a question? I asked you a question. Can you answer it?
You don't even know what your model is.
Can you answer the question? I'm trying to have a super good faith conversation with you. You just seem like you're rage quitting every single question I ask you.
That's what you're doing. You're asking me what a quark field is because you don't know.
I'm not asking you what a quark field is. I'm asking you if you know what a field is.
Why?
Because if you don't know what a field is...
I gave you my definition of what a field is.
Jordan,
you can give yours, I guess.
I have to mute you, I'm sorry. Look, I am asking you if you know what a field is, because if you don't know what a field is, that's fine. I will just have to explain it to you to explain what a quark field is, because a quark field is a type of field. And so I'm asking a clarifying question to make sure that I don't need to explain something you already understand.
Okay.
Got it?
You can give your definition for a field.
Okay. A field is an attachment of properties to every point in space-time.
Yeah, so a coordinate system, just like I said, the points are coordinates.
But no, it's not a coordinate system. The field is the properties that are attached to every point in space-time. But, you know, hopefully you understand that. And then the quark field is a specific
How do you define the
set.
points with a coordinate system?
The quark field is a specific set of properties that are attached to every point in space-time. And we can give those,
these points.
Give names
Where
to
are
those
these
properties.
Points? They're in your head, right? You just you scribble them on paper or computer programs?
Points are
Where
places.
Are these points?
They're like here and there. And
how do you define where the points are?
You can like point to them if you want to.
Oh, where are they? Are they in reality, or are they just in your model that you made up in your head?
Points are like places. Do you think that like places don't exist?
I mean, you're the one saying that they exist. I don't know. You're the one saying
you don't know if places exist. Wait, you don't know if places exist?
Where are these points? Point them out.
Yeah, here, I'm doing it. I'm pointing them out right now.
Okay. And that's a quark field?
No, those are space-time points.
Okay,
the quark field is attached to each point in space-time.
Okay, and so the quark field
attaches properties to each point in space-time. That's what the quark field is.
Okay. So the okay.
Okay.
A quark field is what is it's points in space?
No. I've explained this now 3 times. Can you just listen rather than just assuming that I'm saying points in space? The quark field is the attachment of a certain set of properties to each point in space.
It's so the attachment of properties to points in space.
Yep.
So, okay, so everything, the Earth, everything is made up of attachments to points in space. Of attachments of properties to points in space, right?
I mean, the way that we could describe the Earth at its most fundamental level would be a set of properties at each point in space, yeah.
Okay. What is space?
The thing that you're standing in or sitting in.
Okay, so the Earth came from space.
The Earth is in space.
Well, you said, I asked where did, or oh yeah, wait, no, you said
so.
Where does the Earth
just to be clear,
from?
this is like completely irrelevant because the point I was making at the very beginning.
So you're Jordan, saying it came
the point from space? The point I was making initially is that questions about like how the Earth formed, we now know the answer to, and the ancients absolutely didn't know the answer to that. Now we might not know, what's the fundamental nature of like microscopic black hole, but that's not relevant to asking. Well, how did like the Earth is made of rocks? But it's a big ball made of rocks. How did those rocks come together? We now know the answer. The ancients didn't know that.
It just magically appeared in the quark field one day. Just walking down the street. Boom,
I don't know why you're being so bad faith here. Do you agree that we know more about how the Earth formed than the ancients did?
That's my problem with you guys. You act like, oh yeah, we know where the Earth came from. Oh, I'm Mr. Science Man. I can tell you where the Earth. No, you can't, bro. It's a mystery.
Jordan, I just gave you the answer. It formed gravitationally in an accretion disk. That is an answer to the question of how did the Earth form.
Okay, sure it did, bro. Like what? See, that's the thing. If you make statements like that are so unverifiable, then every statement you make is just garbage.
Why do you think that's unverifiable?
The Earth formed in an accretion disk. Okay, sure it did. Prove it. Go.
Yeah, well, so science is in the business of evidence. It's not in the business of proof. You understand that, right?
I guess. You guys,
okay, so
nothing
all I need to do is provide evidence that this is the case. Right?
Okay, well, I'm glad it's not proof. Yeah, so you haven't proven anything ever.
Science is not in the business of proof.
Great. You guys should stop saying that it is then, because you guys.
I never do.
Oh, so the age of the Earth isn't proven?
We have overwhelming evidence that the Earth is 4.5 billion years old.
But it's not proven.
Science is not in the business of proving. It's not in the business of proving things true. It's in the business of proving other things. It's in the business of proving false things false.
I guarantee I could find like 5,000 scientists that would say we've proved the age of the Earth. But I think you guys
speaking loosely. You're not talking to them. You're talking to me.
Yeah. Okay, well, I'm glad.
So look, it seems like you're just dissatisfied that science isn't giving you all of the proof that you want for the questions that you think science should be able to answer. And like, fine, you can be like skeptical if you want, but then I don't understand why you would then turn to something that has no proof, has no evidence, and then believe that. It just seems inconsistent.
Because the way, I mean, okay, first of all, like, I don't think you really characterize what I'm doing quite right. Like,
sorry, I didn't hear you. I was drinking water.
It's not that like, it wasn't deep enough for me. It's just the fact that you guys act like it's so deep and so fulfilling and so smart and great when it's not. It's my problem is like,
is this like a sociology issue?
As like, pardon?
Is this like a sociology issue? Like you're just upset that like people who study science act certain ways, and so you decided to believe something that's like demonstrably false?
No, that's a separate issue. I can get to why I switched to Christianity if you want. But
I agree that it's a separate issue. Go ahead.
Yeah. So, but I mean, I just think you guys act like you're so smart. Like the way the Earth was made in a accretion disk. Like, what? It was? You don't question that at all? Like, what?
People do question it. And then we studied it more, got better evidence, and then we all said, yeah, you know what? The evidence is actually really good. This is a reasonable thing to believe.
Okay, well, let's go to some like the relevant question here, which is the age of the Earth. Like, have you really questioned? I don't think you guys really deeply questioned
I've
it.
looked at the evidence myself, personally.
Okay, like one time?
I have the papers. I can show them to you if you want.
Have you questioned them deeply?
You read them, and that involves reading the methodology and checking to make sure that it's sound.
Right. Did you really checked? I just don't believe you guys checked.
I literally read the papers. That's part of doing science.
Maybe even like you might be the person who's on TikTok who has looked into this the most, right? And I still don't believe that you've questioned it deeply. But everybody else.
What does it mean to question it deeply? You see the evidence, you check the method, it checks out. You say, you know what, this is good evidence. Then you go look at other evidence. You check the method, you check the data, it checks out. You say, oh, this is good evidence too. I guess we have two good pieces of evidence. And you keep doing that, and that builds your credence in a position. And eventually you come to the conclusion that my credence should be very high in this particular view because the evidence is strong for it.
Do you think most people that believe the Earth is billions of years old study it deep enough and actually question it deep enough to have a legit opinion on it?
I think that most people who are not involved in science, if they want to believe true things, they should generally, like, if they want the best odds of believing true things, they should generally just go look at what the scientific consensus is on some particular topic and then believe that. That's most likely to get them to the right answer.
Right. But that wasn't my question. Do you think people actually look into it deeply enough to have
no,
like
and I don't think that they need to. All that's necessary for a layperson, right? All that's necessary for a layperson is to just listen to what the scientific consensus is, and they will be right most of the time. That's just as good a reason.
Okay, so I'm glad. So you don't think so you think it's fine, which isn't what I asked. I didn't ask if you think it's fine that they just believe the consensus. I asked, do you think like, and the obvious answer is, nobody really looks into this. Everybody.
Well, scientists do, but lay people are not scientists. We don't have an expectation that they do this. No.
Yeah. So most people who promote the idea of the age of the Earth are shallow, haven't questioned it.
Most people who promote the age of the Earth are scientists, right? Those are the people doing writing the papers on the topic, promoting it.
No, there's tons of people on TikTok streaming and
wait,
they say,
so hold on.
Science.
I'm sorry. I thought that your original contention was with like science, not like randos on TikTok.
Well, I'm using this to make a broader point. So like,
what's your broader point?
The fact that people don't question the science when it comes to the age of the Earth generally, even though you might, which I don't believe.
Well, the scientists
do. The fact that people don't question
people don't.
it is an example of the whole scientific endeavor, the whole scientific community. They speak as if like, oh, we know things. Like we're 100% sure. But they're actually most of the time very, very shallow.
Well, to be clear, saying we know things and being shallow, in fact, even knowing things and being shallow, are not mutually incompatible. Being shallow, that's like a weird subjective judgment that you're making based off of kind of vibes, I guess. But like, it is the case that insofar as anybody really knows anything, we know a lot, and we have the scientific community, the scientific method to thank for that.
I mean, there's a lot of stuff, like obvious things, like I don't know, Newton's laws. Yeah, you can test that, you can observe that. But when it comes to the age of the Earth, you weren't there. There's a lot of things that are
your standard?
easy to know.
You just don't like you have to be there in order to know that it's that like the evidence points to something true. Is that your standard here?
I think being able to observe and repeat and test theories shows that they're correct, right? But you can't actually repeat unless you're alive for, I don't know, 1 billion years. You can't actually repeat it and test it.
But see, look, this is an issue because you don't hold yourself to the same standard for your beliefs. You're criticizing scientists for a set of beliefs. I'm trying to tear you guys down before I build Jesus up. So you're criticizing scientists for a set of beliefs, which are based on evidence rather than proof. But evidence, that's what we do in science. Whereas the view that you hold, you don't hold yourself to that standard. Instead, you say, well, we don't need proof. We don't even need evidence. We just need faith. How can you not see the hypocrisy here?
I mean, because I think if you're going to go with a biblical worldview, today, I think, like specifically on the age of the Earth, I mean, probably the biggest mental block you'll have is the quote unquote science, right? It's like, how can I believe the age of the Earth? Like if you're like, it's the reason why it's hard to believe is because we have all these scientists that are saying like, no, like you're dumb. The science proves.
No, the reason why it's hard to believe is not because of the scientists. It's because of the science.
Right, sure. According to you, right? A scientist saying that. The science, quote unquote.
Well, I can show it to you if you want.
Yeah, I would love to. I think, we'll look at how deeply you've questioned your methods, and I bet you haven't really done your due diligence at all. But my point was that like the biggest hurdle people have is the quote unquote scientific community in believing the age of the Earth. And so if you just throw that out into the garbage where it belongs, in my opinion, then it's a lot easier to believe the age of the Earth in the Bible.
I agree. If you throw out the entirety of science, yes, it is easy to believe that the Earth is 6,000 years old. I agree. But
I wouldn't throw it all out. Just your dating.
Just the science that disagrees with your faith.
Just the science that's not observable, testable, repeatable, right?
So to be clear,
like evolution,
do you think that we can observe?
Just kind of like.
Do you think that we can observe, test, and repeat the decay rate of uranium?
Yeah, probably. Yeah.
Okay, so that's observable, testable, and repeatable. Do you think that we can use the things that we learn, the facts that we learn about observing, testing, and repeating uranium to figure out how long the uranium has been decaying for?
Over a period of 6,000 years, or no, I don't think you can extrapolate like that. No, I think that's
so. In your view, you can't know anything
controlled in a lab.
So in your view, you can't know anything about how fast uranium decays when it's just sitting out there in a rock?
You don't know if it's just, you don't know what happened it's just sitting there on a rock. How do you know it's just sitting there on a rock?
Well, I'm asking you, if uranium was just sitting there on a rock, do you think that we'd be able to know anything about how quickly it was decaying?
Maybe, yeah, I guess. If it's on a rock somewhere, I don't know. Don't you do these things in a lab? I'm saying, I mean,
the whole business of science is being able to. So the whole business of science is about making predictions, right? And the better you get at science, the better your predictions get.
Yeah.
And so the point is you do a lot of science to pin down some features of the world. Say, maybe you're Galileo Galilei, and you try to figure out. You drop a whole bunch of weights from the top of the Tower of Pisa. And you figure out that it doesn't matter how much they weigh, they always fall down at the same rate. Now that was the experimentation, the observation, the testing that he was doing. And then he concluded that must be true about the whole world, that everything falls at the same rate, not just the weights that he dropped off of Pisa. Do you think that was unjustified?
No, I think I'm fine with gravity. You know, gravity I can see with my own eyes.
Well,
but
wait a minute, but that wasn't the question. The question was, do you think it was justified for him to conclude that everything falls at the same rate just by testing, you know, a few cannonballs that he dropped from the Tower of Pisa?
Well, not everything falls. I mean, what if you're in space?
Everything on Earth. That's why I said everything on Earth.
Oh, everything on Earth. I mean, at the time, you know, I don't know if that would be justified at the time, because who knows? Maybe the gravity changes somewhere else. Like, how would you know if you're just discovering this phenomenon?
I'm asking, do you think that it would be justified to hold that belief? Not that it's like 100% certain. I'm asking, is it justified to hold that belief?
Today?
If you were Galileo, would Galileo have been justified in holding that belief?
I don't think so. Who
no,
knows?
You don't think so. So he dropped a whole bunch of different weights off of the Tower of Pisa, but actually, let me rephrase the analogy. You're not Galileo. Let's say you're his neighbor, right? So Galileo tells you about how he did this. He like dropped like a 1 pound weight and then a 5 pound weight and a 20 pound weight, and they all hit the ground at the same time. And he tried them with different sizes and different weights, and they always hit the ground at the same time. And then he tells you about this, and he says, so yeah, I've concluded that regardless of what you drop on the Earth, it'll always hit the ground in the same amount of time. It always falls at the same rate. And are you telling me that you would say, that's ridiculous, that's so unjustified, how could you believe that? You don't understand anything. Is that
no?
Is that
no? I'm saying in the geographic location where Galileo discovered it, yeah, that would be justified generally. But they didn't even discover the New World yet.
He didn't test it in his house. He tested it on the Leaning Tower of Pisa.
Yeah, okay, but if at that time you're just discovering this phenomenon, would you be justified to say everywhere on the entire planet has the same rate of fall? I mean, I wouldn't. No, at that time, maybe the gravity's different somewhere else. I don't think that's so crazy to believe. Like, you know, they don't even know how big the Earth is. They don't know where the end of the Earth. They don't know anything at that point. So of course maybe there would be different gravities somewhere else. That would be totally plausible for you to think. And to assume that it's the same everywhere, like the same rate everywhere on Earth, I don't think that's a valid assumption.
Would it be valid for him to infer that it's the same rate in his home as it is on the Leaning Tower of Pisa?
Yeah, that's fair. Yeah.
But he didn't test it in his home. He tested it on the Leaning Tower of Pisa.
Okay, but he's close by.
So it sounds like what you're telling me is that we can actually use information that we gain from a laboratory experiment to infer the way that things will behave in nature.
But the rate could have changed at his house. You'd have to go test it at his house.
Okay, so now you're saying that it wouldn't be reasonable. Now you're saying it wouldn't be reasonable for him to believe that.
Yeah, I think maybe I gave the wrong answer. I think actually, because I wasn't thinking of Pisa. So if he did the experiment at the Leaning Tower of Pisa, I think
let's say his house is like, down the street.
At his house is up for debate.
Let's say his house is down the street.
Could be different. Maybe there's some gravity. I mean, if you're just discovering.
So in fact, if you were his neighbor and he were telling you about this, you would think that he's being unreasonable.
If he made the claim that I know for sure it's going to be the same rate at your house. No,
that's not the claim. He said, yeah, so I did these experiments. I think I'm justified in believing, or rather he just says, so now I believe that the rate at which things will fall in my kitchen is the same. That regardless of how much it weighs, it'll hit the ground at the same rate.
I'd say it's probably pretty close, but I don't know if it's the exact same. If he said that, I wouldn't be like, yes, sir, it is the same everywhere on Earth automatically.
The question is not certainty. The question is it reasonable to believe?
I don't think so.
Okay. So in your view, it's not reasonable to believe anything about the natural world based on any experiments performed in the lab.
Now you're straw manning.
So this isn't a straw man. I will tell you how I got to this conclusion. So the analogy points out that you think that you can learn something about what's happening at the Leaning Tower of Pisa, and that does not necessarily say anything about what happens in your kitchen. Because you said it's not reasonable to believe that it'll be the same in your kitchen. And so if that's your conclusion, that you can only know about the stuff that you explicitly tested, you can't then apply that knowledge to other situations, it seems like we can never make any predictions about the natural world. We can never make any inferences about the natural world, because anytime we run a test, we're doing it in a laboratory environment, or we're doing it in a controlled environment. We can never make predictions about things that we haven't tested in situ. which means that, you know, we can't say that, I don't know, we can't say that a tornado is going to go in this direction because we haven't measured that tornado yet. We can't say that, I don't know, that this volcano will erupt in a day because we haven't measured that volcano yet. We can't make any predictions in a justified way at all. Sounds like.
So do you think that it's good to verify? Like, do you think it was good? Like, do you think they should have done the gravity test, like Galileo should have done the test elsewhere? Or do you think just one was good enough?
To be clear, he didn't do just one. He was doing it on the Leaning Tower of Pisa with lots of different weights.
Do you think they... Yeah, so... But Leaning Tower of Pisa, check it there. Don't check anywhere else. It's definitely going to be the same, so don't even worry about it.
To be clear, I never said that. The point is that it was justified to believe that it would be the same.
But do we have to verify it at all or no?
Who's we? Are you talking about scientists? Or are you talking about like lay people?
Generally. Or people who care about...
Scientists wanted more precision measurements, wanted to figure out how quickly things fall, what changes the effect, because, you know, we did eventually find out that actually things don't all fall at the same rate, and we figured out that's because of air resistance, and, you know, it got more complicated. But the conclusion is that, you know, the first order correct conclusion is that, yeah, things on Earth fall at the same rate. And then there's like modifications and stuff that we learned about more. But that would be absolutely...
Why would you double check it elsewhere? Why double check it at all?
It's not about double checking it. It's about getting better precision.
Yeah, why?
And by the way, you absolutely can double check it elsewhere. If Galileo checked it in two different places, if Galileo checked, let's play with your idea. Let's say Galileo did it on the Leaning Tower of Pisa, and then he did it on some other tower, like, I don't know, on the other end of the city, say, right? Would he then be justified in believing that things will fall at the same rate in his kitchen?
I mean, no, but you're not answering my question.
Look, so
why would you double check it?
Verifying scientific experiments is like part of the scientific process. You always do these things more than once. So I just asked you, what if he did it twice in two different places? Would he then be justified?
I don't think so. No.
Okay. What if he did it in three different places, but not his kitchen?
I'm genuinely looking at this example. No, I don't think if you're just I don't think you would assume it's the same everywhere. I don't think that's a valid belief.
So even if he does it in three different places, none of which are his kitchen, and he gets the same answer, he cannot then reasonably infer that things will fall at the same rate in his kitchen.
I mean, I think there's like a cone of uncertainty, like, yeah, like the geographical area. If you do it a few times in the city, maybe, yeah, that whole city is going to be the same. That's fine. But then to leap across the entire world and say it's going to be the same over there, I think that
wasn't my question. My question was about his kitchen.
Yeah, his kitchen. No, when you're no, I don't think so.
Okay, so it doesn't matter how many times you test it, unless you test it in the specific situation that you're trying to make claims about, then it's just not justified to believe anything about that situation. It sounds like.
Well, we're talking about gravity specifically. I mean,
we're talking about science. This is an analogy for the whole scientific process.
Your analogy is about gravity specifically, and
yeah,
I think
sure.
Maybe gravity has a unique potential for variability across geographic locations. That maybe like if you measure, I don't know.
By the way, it doesn't.
Would be
so
more repeatable.
Things fall at the same rate everywhere in the world. Now that rate that they fall out might be different in different places. That rate that they fall out might be different in different places. But if you take two things, modular air resistance, of course. If you take like a small lead ball and a big lead ball, they will hit the ground at the same rate regardless of where you are on Earth.
Yeah, I know, but how would Galileo know that? How would he know that?
So it sounds like you're saying that there's no way for him to justify that if he takes two different sized lead balls and he drops them in his kitchen, that they will hit the ground at the same time. There's no way for him to justify that belief unless he's actually done it in that place.
I mean, no, that's not. And I already explained what I'm saying, but like, my point is that like the closer you are to, so if you do a test at Pisa, and then you do a test like,
a building a few blocks down,
you're probably gonna be like, yeah, it's probably the same. But if you're going all the way across the world,
nobody's talking about going across the world. We've narrowed the analogy, and we've been on a narrowed analogy for like 10 minutes now. Like,
but even if it's like down the street, it still could be different. So I don't think
you're telling me that if
I think you'd have to test it.
So
you'd have
Jordan,
to test it down the street too.
So you're his neighbor, Tony, right? Galileo tells you, yeah, so I tried it on Pisa, and these two hugely different lead ball sizes, so one's like maybe an inch across and one's like 6 inches across, they hit the ground at the same time when I dropped them from Pisa. And then I went to the Peening Lower of Misa a few blocks down, and I tried it again, and they hit the ground at the same time there too. And then I went to the Beaning Lower of Kisa, just a few more blocks down the road from that, and they hit the ground at the same time when I dropped them there too. Now I'm going to go into my kitchen, but I think if I drop them in my kitchen that they'll hit the ground at the same time. And you would say, nah, you can't know that. You're not, that's so unreasonable.
Probably. I would say probably, but you don't know for sure.
Would you say that it's reasonable for him to believe that?
No, I don't think so. Not at that point.
Okay.
No.
Why not?
For me, belief means like you're very sure, right? You're very sure that it's going to happen. And if it's only like the third test, who knows?
How many tests would he have to do without doing a test in his kitchen? How many tests in his town would he have to do?
Wait, how many tests in his town to know if his kitchen is the same? I don't know. Like, I don't know. Maybe I don't know. I don't know. I mean, can we take this to zircon dating, to like a real world application? Because I think there's like a gradient.
Not until we finish the conversation about the Leaning Tower of Pisa.
I think there's a gradient of certainty, because I would be thinking, oh, maybe there's like a gravity wells that like change the rate somewhere. I don't know. Well, actually, you know what? I guess people would have experienced gravity wells. So, but I don't. Yeah, no, I don't know. I don't know. It's 5, 7. Like, how would I?
Okay, 5, 7. Sure. That's enough to get you to
believe that,
to some maybe 95% or something like this.
Yeah.
Okay, let's say 7.
Yeah.
Okay, so he has to test it 7 times. Okay. Do you think that standard is like reasonable for like other scientific things? Like if somebody tests, if you have like 7 people testing something in different settings, and they all get the same answer, that's reasonable to think that will apply in an 8th setting?
I mean, yeah, I don't know. I'm hooked on the word belief here, because it's like
belief is just an attitude about a proposition.
But here's the thing. So you're using this to equivocate zircon dating, but I don't think it's a one-to-one
equivocate.
Comparison. I think dropping a bowling ball in the city.
I'm talking about uranium decay rates, right? We haven't even gotten to zircon.
Okay, uranium. Okay, well, you're talking about uranium. I don't think it's a one-to-one. You're using this as if it's like a one-to-one comparison to.
Well, look, you can measure how long it takes for 2 differently sized lead spheres to hit the ground in Pisa, and you can do that 7 different times in different places, and you'll get that they always hit the ground at the same time. Similarly, you can go measure 7 different samples of uranium at 7 different times in 7 different places, and measure the decay rates and get the same answers.
But because you have a control, you have a laboratory control for the decay rates.
What are you controlling about the decay rate? It's just like a lump of uranium. What are you controlling?
You're taking a lump of uranium and then you're measuring the zircon. How much?
I'm not even talking about zircon. I'm just talking about decay rates of uranium, how quickly uranium decays.
Okay, so you're measuring, but what does it decay into? Lead, right?
Well, not directly. It decays into lead eventually through like 10 or 11 or 12 different steps.
Right, so you're measuring this rate over time.
Mm-hmm.
You're I don't know how what? You're using just uranium half-life to age things? I thought
we're not even there yet. We're not even there. We're just talking about how long does it take uranium to decay? What is the half-life of uranium? That's the thing that we need to agree on before we can even move on. This is like something that like is consistently, or that is behaving consistently across time and space.
I guess. I don't know. Have you done it? Have you? I mean, it's probably the same, I guess.
I've looked at the data.
Right?
I haven't personally done it. If me personally doing it is the standard required, then like, I don't think that you can believe anything.
I mean, I don't even. So you're saying you take 7 samples of uranium and you measure the decay rate. They're the same everywhere.
No, what I'm saying is you have 7 different groups of people, each with 7 different samples of uranium in 7 different places at 7 different times, all measuring the decay rate of uranium, getting basically the same answer.
Okay. Yeah.
And
then
honestly, it's probably on the order
same.
of dozens, if not hundreds, rather than 7, but 7 was the number that you said.
Yeah. So, yeah, there's probably a decent certainty. You're probably fairly certain about that, yeah.
Right, so it would be reasonable to say that, oh, if there was just like a uranium lump sitting out there in nature, we would be reasonable to infer that it decays at the same rate that we measured those 7 different times.
Yeah, I think so, yeah.
Okay, and what if would we be reasonable to say that 50 years ago it was decaying at the same rate?
No, I don't know.
What if we measured the decay rate of uranium over like many different times over like 100 years by different people, different places, different times over the course of 100 years, and you still get the same answer? Then would it be reasonable?
Well, it's definitely not going to be exactly approximately the same answer.
Within experimental bounds, right? Like every measurement has experimental error, so within experimental bounds, the same.
Yeah, I mean that's a pretty small time frame, like relative to the supposed age of the Earth. But yeah, like I guess it would be consistent over that time period, sure.
So
hypothetically,
wait a minute. So you're telling me that if we haven't measured it prior to 100 years ago, we can't say anything about what uranium was doing 200 years ago?
I mean, maybe you could. I don't know how similar the measurements are. I haven't looked at them. Have you? This is the thing. Like, have you really questioned this?
How many times? So I've looked at uranium. What is it called? Radioactive decay rate measurements. Some of which are very recent, and some of which are very old, like 70, 80 years old.
Okay, so 80 years ago. So okay, I'll give you. Okay, the uranium decay rate will stay the same within 80 years. Probably.
But why are we just limiting it to 80 years? I thought we just established that if you do the experiment enough times, then you can infer it, even in the setting that you haven't actually measured it in.
No, I was saying with the gravity thing, you could go around pretty close with certainty, relatively, but across the world, no. And so, I mean, if you want to go back 80 years, you have measurements there. Maybe you can go back another 100 years, maybe. I don't know.
How many measurements so is it your view that we can't know anything about the rate at which uranium was decaying 500 years ago?
How would we know? I don't know. Can we know?
That we can infer anything about it? Can we reasonably infer anything about the rate at which uranium was decaying 500 years ago?
You're the one claim that you can, right? Why am I on the defensive? You're the one saying that you can.
I'm asking you whether or not. Look, I can justify it. I'm just asking you before I justify it. I'm asking you if you think that we can. If you think that we can. If not, then I'd like to know why you think not, and I can explain to you why we think we can.
I don't think you can.
Okay.
500 years. I don't. How would you be able to confirm that?
Well, look. So the whole business of science is we take data in the here and now, and then we use that to infer facts about the world elsewhere and elsewhen. And fortunately, things like decay rates, they're not just merely empirical things. I mean, like perhaps they were 100 years ago, they were merely empirical things. We didn't understand why they decay at the rate that they do. We now actually understand why they decay at the rate that they do. These are essentially laws of physics. And unless you think the laws of physics were different 500 years ago, that gives us justification in thinking that if the laws of physics were the same, then the consequences of the laws of physics, like the uranium decay rate, would also have been the same.
See, this is where it's like, oh, the laws of physics. Oh, if you disagree with me or if you question me, you're questioning the laws of physics. I don't think you actually understand the laws.
I didn't say that at all.
That's what you said. You're basically saying, I'm paraphrasing, that you're saying that we know the decay rate extends past 500 years accurately because the laws of physics dictate it must.
No, I said that we now understand the origins of the decay rate now, right? The decay rate now and the decay rate that we've measured in the last 80 years or so,
and that's
we understand
why
the origins of it. We can derive these decay rates. We can understand why they are the value that they are based on more fundamental laws of physics. These are no longer merely observations. They are now things that we can understand the origins of, right? And so if those origins merely come from laws of physics, then we have a good reason to think that if the origins are stable, then the outcomes will also be stable, right?
Yeah, I mean, you just explained, I mean, whatever. I think you just repeated basically what I said, but
do you agree that if the origins are stable, then the outcome should be stable too?
Yeah, that's a big if.
Right. So then then it seems like your contention is you don't think that we can justifiably believe that the laws of physics were the same 500 years ago as they are today.
But that's you're assuming that you understand the laws of physics. I mean, what are these origins?
No, I'm assuming that they're consistent.
Predict decay rates. Please enlighten me.
So
I don't think you really. I think you just pulled that out of a hat.
The way that we understand decay rates is, I mean, it depends on the kind of decay rate. For example, alpha decay is quantum tunneling. You can model alpha decay via quantum tunneling, where you have an electromagnetic energy barrier blocking the alpha particle from escaping the nucleus, and you can predict the size of that that electromagnetic energy barrier based off the atomic number, and the atomic mass. And then you also need to make measurements about the shape of the atom as well, so then you can get something about the distribution of that nucleonic matter. That's one kind of decay. Actually, I think that uranium is an alpha decay. I think that it's an alpha emitter. So this would be the kind of physics that is used to predict the decay rate of things like uranium decay, and uranium decay in particular.
What's an alpha particle?
It's composed of, it's a helium nucleus. It's composed of 2 protons and 2 neutrons.
And the protons and the neutrons, those are quarks, right?
They're bound states of quarks, yeah. It seems irrelevant, though. Yeah. You don't need to know what the quarks are in order to understand how alpha particles behave.
I mean, so you're telling me you know what an alpha particle is and how it functions, but you don't even know what it's made out of, really?
Well, we do know. We know that they're made of protons and neutrons.
Yeah, but the protons are made out of quarks, and the quarks are the quark field.
But look, that's not about what the alpha particle is made out of. The alpha particle is made out of protons and neutrons. That's what the alpha particle is made out of.
But this is what I mean when I say you guys don't really go that deep, because if you keep zooming
you don't need to go deeper than it's made out of protons and neutrons to understand how radioactive decay works. No. Well, no. In order to
is that like a forbidden
Jordan,
zone?
This
where
is
I'm
so
not
bad
to go?
faith. Jordan, if I wanted to understand how, let's say I wanted to understand something.
Not allowed.
Jordan, let's say I wanted to understand something fairly straightforward. I want to understand. I'm just trying to think of something that's like super basic. Oh yeah, how about this? Let's say I want to understand why it is that when I combine these 2 chemicals, actually no, why is it that I need to understand, what do I need to understand in order to figure out why it is that when I put a fire under an ice cube, it turns into water? What do I need to understand that in order to understand why that happens?
A lot. I mean,
really?
That's the thing. I don't think you really. I don't think anybody really understands how fire works.
Do I need to understand what quarks are in order to understand how ice melts?
You guys act like you have understanding, but you don't really.
Do I need to understand what quarks are in order to understand how ice melts?
Nobody really knows.
Do I need to understand how quarks work in order to understand how ice melts?
Yeah, I think so. Yeah.
Oh.
Otherwise, you don't even know what you're talking about.
Oh, okay.
It's just something. Like
so
you said, what is a quark?
So you don't actually... How far did you get in physics? Because you said that you were studying it, right?
I dropped out when the professors were making me do dumb things for hours for no reason.
Are you talking about homework?
Matrix blocks. Like, what's the point of that? I can go on Google.
Are you talking about homework? You dropped out because the homework was too hard?
Yeah, I had access to Google. Why would I waste my time? And if I want to learn, doing these like jumping through hoops like a monkey for a cookie when I can just go on Google and talk to the PhDs right there? It makes no sense.
Wait a minute. I thought you dropped out. I thought you swapped out or left physics because
I was an
they
engineer.
didn't have a deep understanding.
I dropped out twice because it was dumb, waste of time.
Wait, so what? So maybe I just misunderstood. So did you start as a physics major?
I started Bachelor of Science and then I went back for engineering and I dropped out of both.
And at what point did you drop out?
First year, both time.
First semester?
Well, no, second year, first time. Second year Bachelor of Science, first year engineering.
Mm-hmm. And you dropped out because, not because of a lack of understanding, but because of the homework?
Yeah, waste of time. I have Google.
So
because I don't care.
Why'd you lie to me about
having
saying that you stopped paying attention to science because of the lack of understanding? It was because of the homework.
No, I was studying. I kept studying science when I dropped out. But I don't care about having a doctorate beside my name. I don't care about the badge. I care about the actual wisdom, right? I don't care if somebody at a university with a degree gives me a piece of paper. That's not what matters. What matters is the wisdom and the knowledge. And if you want the wisdom and the knowledge, you can go on Google.
You were studying it and then you stopped. I guess I inferred when you said studying that you meant like in like a formal setting. Do you think that like homework's not valuable? Do you think that the ability to do like math? All the time. Do you think that like the ability to do like mathematical calculations is not valuable for an engineer?
If it doesn't have a practical application, I don't think it's very valuable. No. If you're just jumping through hoops for no reason.
So matrix multiplication is like one of the most valuable things that like any engineer, any computer scientist, any scientist can learn.
Yeah, but only when it has. If you're just doing matrices in your room on a mountain by yourself, nobody cares. It has to have a practical application to the world.
The reason why they assign that homework is so that you can learn how to do it, so that you can reliably do it in the future when you will have to. What if I learn how to do it in 10 seconds, and then they give me 8 hours of homework? I already know how to do it. What's the point of that? To make sure that you know how to do it, because I can assure you that if they just instructed you on how to do it and then gave you an exam on it, you probably wouldn't succeed.
But I get the general principle. That's the thing. I'm looking for the practical application. I don't want, can you do like, because they take these equations, they make them so obscure for really no practical reason. They make them so convoluted.
How can you know that it's not for a practical reason if you failed to succeed in that degree? Are you an engineer now?
There's nothing being produced in the college. There's nothing being produced.
Are you an engineer?
No.
Okay, so colleges, universities produce engineers, right? That's one of the things that they do.
Yeah, but they don't make products that are, they don't make any products.
The engineers do. You wouldn't have engineers if you didn't have education.
Elon Musk doesn't. Elon Musk specifically said he doesn't care if you have a degree. So, I mean, there you go. One of the best engineers in the world doesn't care if you have a degree.
Elon Musk dropped out of a physics program.
You can self-teach. You can self-teach. It's fine.
Okay, and self-teaching means doing the practice, right? Also, Elon Musk isn't an engineer; he's a businessman. So
self-teaching means focusing on the end result and getting.
No, it doesn't. I mean, like this is neither here nor there. It's not really relevant to the conversation, but it does kind of illustrate your like the way that you think about these things, and it's kind of illuminating. But look, so it sounds like, just to kind of walk the question back, just so then we can get back on topic, it sounds like your contention is that we can't understand how, this is where we were, then I asked that question, we can't understand how ice melts without first knowing how quarks work.
Yeah, pretty much, yeah.
The reason why I asked the question how far you got in physics was because there's a whole business of, there's something called an effective field theory, which is like a more sophisticated way of describing coarse graining. Do you know what coarse graining is?
No.
So coarse graining is basically when you kind of not throw away, but when you kind of ignore, when you don't pay attention to information that is small scale, because all you need is the large scale average behavior in order to describe something adequately.
Adequately to you.
Yeah, in order to like make good predictions about the way it behaves, right?
Wait, can you repeat that?
In order to make good predictions about the way it behaves.
Yeah, I guess you can predict stuff generally, yeah.
So like if you want to have a good grasp on how things work, one good way to show that you have that good grasp is to be able to make predictions about how it will work in other settings, how closely related things will work. Because if you can predict the future, that must mean that you know something about what you're trying to predict, right?
Yeah, I guess kinda.
So
you know
you can
something,
throw
I guess.
away. You can throw away all of the information about quarks. You can throw away all of the information about protons, neutrons, about electrons. Really, if you want to make really, really good predictions, you might need to know stuff about like maybe thermodynamics, maybe statistical mechanics, maybe crystalline solids in order to make good predictions about how ice melts. But you absolutely don't need to know anything about quarks. So to say that you need to know about quarks in order to understand why ice melts just seems silly.
Well, I think, you know, just because you can make some predictions doesn't, like, when you say how ice melts, just because you can make some predictions about when it's going to melt doesn't mean you actually understand it. How it's working, the mechanism behind it. Yeah,
the mechanism is fully,
you know something about it.
The mechanism is fully accounted for by the coarse-grained information that you need, right? There is not a single piece of information that you need to know about quarks in order to fully describe, capture every single aspect of ice melting. You don't even have to think that, you don't even have to know that quarks exist in order to fully describe how ice melts.
You can know, maybe
fully characterize it.
You can predict the rate at which the ice will melt, but you don't know what, that doesn't mean you know what fire it, like, that doesn't mean you understand the process fully, which is what you're saying. You're saying
no, you do. Like, so the quarks are not involved in the process of ice melting.
That's ridiculous.
You can say it's ridiculous, but I urge you to find me one way in which not knowing about quarks would.
You just said quarks are not involved in the melting of ice. Go tell
they're not
that
involved
to
in the process.
See if they take you seriously.
Whether or not quarks even exist is irrelevant to the complete description of the way that ice melts.
So, are you backtracking on what you said? Do you think quarks are what did you say? Do you think quarks are irrelevant to the process of ice melting?
I mean, quarks make up things that make up ice, right? So, like, quarks are going to they're going to be involved in the sense that, like, they exist, right? But the actual description of the way that the ice melt happens has nothing to do with quarks.
I would say a description, but not the, and definitely not the full description. The full description is definitely going to involve.
Okay, so I challenge you. I offer you a challenge. Find me one thing that you cannot account for with merely a molecular view of water. That requires a knowledge of quarks to understand as far as water melting is concerned. Sorry, ice melting is concerned.
I mean, you're the one making the claim, and you have to prove your claim. You're the one saying that. You're the one saying affirmatively.
I laid out to you this whole business.
Everything is covered without quarks. You're the one making the claim, so you defend it.
And I already laid it out for you. I laid out what effective field theories are, how coarse graining works. I could give you a complete accounting of ice melting in terms of electromagnetic fields keeping atoms bound together towards each other, and the thermal distribution of energy causing the accelerated oscillation of those electromagnetic the accelerated oscillation of the atoms and molecules that make up water, causing those bonds to break, and that will fully account for the melting of ice without ever talking about quarks. Not necessary at all.
I don't believe that's full at all.
Okay, give me an example of one thing. Give me an example of one thing that description will miss that requires quarks.
I don't believe it's full. You're the one making the claim.
Okay, so you don't believe it, so give me an example of what it misses.
I don't have to. You're the one making the claim.
You just made the claim that you don't believe it's full. Okay, what is it missing?
That's not a claim. I just don't. I'm not believing your claim.
Okay.
And I think your claim is unfounted. And I think all scientists, I think probably every particle physicist in the world would disagree with you.
I'm sorry. So you're asking. So I could keep giving you more and more description, and you could always just keep saying, "Oh, that's not full. That's not full." So the claim, what you're asking me to justify is something that you would never accept justification for. So rather than being bad faith and asking for justification when you would never accept justification, instead just justify your own claim. Justify your own claim that that's not a full explanation.
Trying to get a deeper understanding of reality is bad faith, according to you, right? Pointing out that there's gaps.
Suggesting that you need to understand quarks in order to figure out how ice melts, that's bad faith, yes.
You're saying that if you go tell a particle physicist that quarks are not involved in ice melting, they will laugh at you. They will say,
want me to bring up a particle physicist?
Very funny.
Want me to bring up a particle physicist?
Well, okay, you guys are all in a cult, so you'll probably back each other up because you don't really, I mean, come on.
One sec, let me pull them up.
If it was like, if you brought tell this person that I said it, and they'll mock it.
I'll just bring him up.
Yeah,
you can say
tell them that I said it though, because if he knows that you said it, he's gonna back you up. But if he thinks I said it, he's gonna go against me.
One sec, I just got to send him an invite. Alternatively, if there are any particle physicists in the chat, I'd be happy to bring you up. But I'm not a particle physicist, even though I played one as an undergraduate for 3 years. Actually, does that count? I did do particle physics for 3 years as an undergraduate. You there?
Me?
Yeah.
Oh,
does it count? I did particle physics for 3 years as an undergraduate.
Oh, yeah, okay. Is everything you learned on Google?
Is everything I learned on Google? Probably not, actually.
What is
Some of the stuff I was doing was really obscure.
All the textbooks are available online for free?
The particle physics I was doing was not in textbooks.
Really?
At least I didn't learn it in textbooks, no.
Even like a classified military program or something?
No, it's just most research cannot be found in textbooks.
Where is it found then?
In researchers' brains.
Okay.
Things only get into textbooks like 50 years after the fact.
I just assumed it was 3 years of school, but you did 3 years of research?
I did 3 years of particle physics. I was doing particle physics research for 3 years as an undergraduate.
What does that mean?
It means I was involved in...
for 3 years. Okay.
Yeah.
Cool. Congrats.
So does that mean that I'm qualified to say, yes, quarks are not involved in the melting of ice? Am I sufficiently qualified for your view, for your opinion?
How can you say that ice is made up of quarks and then they're not involved in melting? Like what?
All right, so this guy, he hasn't been listening at all. Go ahead and say the thing.
Yeah, quarks are not involved in the process of melting ice. You don't need to go to that level of precision.
What are they doing when ice melts? They're just like, hey, protons, I'll see you later.
I mean, they're composing the structure of those protons, but they're not actually involved in that process. You don't need that level of precision.
They're just the fundamental building blocks of the entire structure, but they're not involved in the transformation of the structure.
Yeah, that's a chemical process.
Do they move at all?
A nuclear one.
They don't move?
I mean, they move
with the atoms. Do the quarks move ever?
But you don't need that level of precision.
Are they involved?
Involved only as so far as that they are just composing the structure. But the actual
the structure moves.
That's a chemical process, not a nuclear one.
So when ice melts, the quarks, do they move?
They move with the atoms.
Oh, so they're involved then, because they move.
They're not actually involved in the process. You don't need to.
They're just moving around
nuclear force.
Changing temperature.
Describe the process.
Yeah. Okay. This is such cope. So, can you show me a scientific research study that proves that quark? I mean, it's just such an insane baseless.
So a particle physicist, somebody who's
what I'm saying. That's
doing his PhD in particle physics, just came on and said,
"This is the standard.
Yeah, you're wrong
you guys
about quarks."
This just exposes your standard because you just make baseless claims. It's like, well, if you're going to make claims like that, then clearly all of your claims are
Jordan, you made the claim not 5 minutes ago saying, go tell this to any particle physicist and they'll laugh in your face. So I brought on a particle physicist and he agreed with me.
Whatever. Okay, I was wrong about that claim. Oh no.
All right, Quantonaut, I'm kicking you off, but thanks for doing that.
This guy's not honest. You're both lying to yourself.
Now it's not, oh, you're just wrong. Now it's, oh, the particle physicists are being dishonest. That's a cool goalpost shift.
Do you think this is a victory for you? I mean, it's ridiculous.
Yeah, I mean, you look pretty bad.
This guy, this is your henchman. You brought your henchman up.
My henchman?
Hey, look, I got my henchman here. He agrees with me. I got my yes
He's
man
a particle
here.
physicist and a friend.
You're missing the point completely. You need a blind study. Your bias is shaping his answer, and that's why he answered that way. If you gave a neutral request to a particle scientist, a particle physicist, then I bet you it would be right. But you loaded it with like.
Have you ever talked to a particle physicist before?
Then that would have caused drama.
Have you ever talked to a particle physicist before?
Yeah.
Do they have a name?
Dr. Blitz.
Oh, okay. So wait a minute. So I'm the only particle physicist that you've ever spoken with.
I don't know.
I'm not still a particle physicist, by the way. Like maybe I was as an undergrad, but I'm not anymore.
No, I used to troll around the physics subreddits, and yeah. So
you've never talked to a particle physicist?
No, I think I have. Well, but whatever. Why does it matter? Is that like a big win for you?
Because you're making assertions about what a particle physicist would say.
So I'm right.
No, Jordan, the reason I ask is because you're making assertions about what a particle physicist would say.
I own 10 Bibles.
You're making assertions about what a particle physicist would say without A, knowing any particle physics, and B, knowing any particle physicists.
No, my assumption is because it's so obvious that quarks are involved. It's
or alternatively, you're wrong, and you're experiencing the dunningest of Krugers because you think that something is obvious when you're not educated on the matter at all.
You have a cult of yes men who will agree with you no matter what, and that's why everybody is in your chat is saying that quarks are not involved. He's right because you have.
Is it possible that you're wrong about this, Jordan?
Cult of personality. Pardon?
Is it possible that you're wrong about this?
I don't even know what a quark is, bro. I don't even know. A quark is just a label.
Is it possible that you are wrong?
I would say it's possible I'm wrong about everything, and it's possible you're wrong about everything.
So
a quark is just a label you put on something. Is it plausible
that you are wrong about particle physics as far as ice being involved in ice melting? Is that plausible?
I mean, I'm not even really making a claim about. I mean, I guess my claim is that. Yeah. Okay. Definitely. I would say it's definitely possible that I'm wrong that about my claim that quarks must be involved in ice melting because I don't even know what a quark is, bro.
Plausible, not possible. Plausible.
It's plausible. Yeah. Yeah.
Okay. So how do you establish if it's plausible that you're wrong about this? Why would you so certainly believe the opposite? With such confidence.
Because the only reason I think I'm doing an internal critique, but it's possible that I shouldn't be internally critiquing. Like it's possible that the whole so when I'm saying
not asking like are you a brain in a vat? I'm asking could the particle physicist be right about this and could you be wrong about this?
I'm saying wait, the particle physicists. I mean you and that other guy?
Yeah, and all of the particle physicists that I've ever spoken with that would agree with me.
No. The internal critique is I'm giving you that quarks exist. I'm letting you have that. Mm-hmm. And the way I could be wrong is if quarks don't even exist. That's what I mean when I say I could be wrong.
Yeah. So you're saying that given that quarks exist, you could not be wrong that quarks are involved in the process of ice melting?
Yeah.
Or that. Yeah. Actually, let me rephrase. Given that quarks exist, you're saying you could not be wrong about the necessity of understanding how quarks behave in order to understand how ice melts.
Yeah.
Okay. You don't think that's possible that you could be wrong about that?
No, I don't. No, because a full description.
So you are 100% certain, you would say, that given quarks exist, then it must be the case. It is impossible for you to be wrong about this claim that you need to understand how quarks work in order to understand how ice melts.
Yeah, because you set the groundwork that quarks. You set the groundwork that ice is made of quarks, right? So if ice is made of quarks, then you have to understand quarks to understand ice.
No, you don't. That's the point.
Okay, says some guy.
I mean, like I explained this whole business about coarse graining. It seems like it went in one ear and out the other ear.
I mean, so you're just talking about reducing the resolution to say some things. I'm saying I agree. You can say some things about ice, but that doesn't mean
you can fully understand the process. using coarse graining.
Yeah,
you don't need to. You don't.
You said
the other stuff is not. The other stuff is not necessary to understand it.
I don't believe that. I mean, I don't believe that. There's a difference between knowing some things about the process and knowing everything about the process. And you're saying you can know everything about the process.
Do you understand, how you get to the grocery store, on Saturdays?
No, everything's a miracle.
Do you understand anything,
point, bro? No, nobody does. Neither do you. That's
Wait a minute.
my problem.
Hold on. Just to be clear, Jordan.
Pretend like you understand
everything. I'm willing
everything,
to grant that you don't understand anything. I don't think that you should assume that about anybody else.
It's obvious. You don't know what you are. You don't know where you came from.
I think that you're just impugning your lack of understanding on other people.
You're just pretending. Your whole worldview is pseudo. It's pseudoscience. You pretend like you understand, but you don't. And that's my problem with science. Is what are you? Oh, I'm a bunch of quarks. What are quarks? Oh, I don't know. It's a field. It's a thing. A field thing. It's space. It's points in space. What's space?
It sounds
I don't know. It's over here. Look, I'm pointing at the quarks, guys. Woohoo! Come.
It sounds like your entire view is based on you not understanding things, and therefore nobody could understand things. Because you think that you're the smartest person in the world, and if you don't understand something, it must be impossible, and everybody else is just being dishonest.
And you think if you pretend like you're super smart and you have a doctor beside your name and a PhD, oh, I must be smart. Look at me and all my smart friends are going to school together. Look how smart we are. Come follow me. I'll take you to the promised land.
Am I intimidating for you, Jordan?
Science is so great, guys. Come along.
Jordan, am I intimidating you?
Calling the kids into the cave. Woohoo! Come here, boys.
Is my education intimidating for you, Jordan? Because it doesn't have to be.
No, it's a dead end. You're gonna be in the dirt. Nobody's gonna care, and that's what my problem is. It's like, like you're not that smart. Your wisdom is not that deep. It's not that valuable. You don't really understand anything. Period.
This sounds like
understand what you are. You don't understand what you are, right? Do you?
It sounds
What's
like
a proton? Oh, a proton is a quark. What's a quark? Oh, it's right here. I'm pointing. That's what you did, bro. That's how deep you go.
So your worldview amounts to nobody knows anything, we can't know anything, so let's just believe in Jesus. Sounds like.
No, first of all, I want to establish that you know nothing, and then once
you haven't
you
done
get
that,
tired of floating in the abyss, yeah, maybe then you would reach out for Jesus.
Once you haven't established that.
You're floating in the abyss of nothingness, then you'll look for a light, yeah.
And surely that's what you did. You dropped out of a science bachelor's because the homework was too hard. You went back for engineering. You dropped out of that because the homework was too hard. And then you realized that, all this is useless. Scientists don't know anything. I found my way in Jesus. Is that right? A good estimate of your life story?
Yeah, I started reading the Bible, and I was like, yo, this is banger after banger. He said, don't worry about this. But
you can't understand any of it. What are you talking about? How do you understand any of it?
Through faith.
Oh, but faith isn't certain. How can you know anything?
I just find it more. I'm not saying it's certain. I just find it more compelling.
Oh, but you don't even understand. You don't even understand the words.
I'd rather hang out with Jesus than a bunch of nerds who die. I'd rather go follow him. I find him a lot more compelling than you. If you're searching for wisdom, I don't think Neil deGrasse Tyson's going to save you, bro. I don't think Sheldon from Big Bang's going to save you. You need something more. I'm not saying I'm certain, but I find Jesus a lot more compelling than you because he has a plan. He's going to come back, save the world.
How do you know? How do you know that was Jesus? How do you know that?
I don't know.
I don't know. So then why do you believe it? You just don't understand anything. You don't know anything.
Exactly. I don't have a math equation I can't go a squared plus b squared.
You don't even know if Jesus existed.
It doesn't work like that. How do I know?
No, you don't know that Jesus existed.
Oh, not for sure. I can't prove it. No.
No, you have no understanding of Jesus's existence. You don't know anything.
Really. But I'm building on him spiritually, right? And
you're building
maybe
on
I'm
something.
wrong.
So you're building on a scaffold that you don't even know exists. You're building on a scaffold that you don't understand. That seems irresponsible.
And so are you. And you want to bet on Neil deGrasse Tyson? I'll bet on Jesus.
That's a description that you are giving to my view. That's not my view, but it is your view that you don't know anything.
Well, you're coping.
So your view,
because you are building on nothing.
Your view is that you don't know anything, and then you're building on top of that lack of understanding,
my view
lack
is
of
that
knowledge.
You also don't know anything.
Well, yeah, but that's an external critique, not an internal critique.
Okay, what are you then? Oh, I'm the quark field. Look at the quark, guys. It's a points in space. Everybody follow me. The quark. follow me to Corkland. We're gonna meet Smurfette and Smurf King in Corkland. Like, it's just ridiculous. So you're building
incredulity
on
is
nothing.
not an argument, Jordan.
You can't prove your worldview. I can't prove my worldview. I'm gonna bet on Jesus. You bet on Bill Nye, and we'll see who's right.
No, I'm gonna bet on evidence.
Evidence of what?
Claims.
All the evidence shows that you're going to the dirt, and nothing you do will ever matter. So enjoy that.
All the evidence shows that, like, the sun is made of hydrogen, for example.
Wow.
Mostly hydrogen, a little bit of helium.
Yeah, what about immortality with Jesus in heaven and all of your?
But where's the evidence for any of that?
I've seen enough evidence. The Bible says seek and you'll find.
Wait, so do we believe? Do we need evidence now? Do we trust evidence or no?
I think evidence is good, but when you take it too far,
you do think evidence is good. What does evidence get you to? Does it get you to justified belief?
It doesn't get you to 4.5 billion years.
It sure
does. It doesn't get you there.
Sure
no,
does.
It doesn't. It says your cult. It says your indoctrination.
What's the evidence for 6,000 years?
I mean, I just find it more. I find the Bible as a whole. More
what's the evidence for 6,000 years? I don't care what you find compelling. What's the evidence?
Oh, I haven't looked at. I don't look at it. Like, I haven't done any math equations for it.
So you just believe it?
If that's what you mean. Pardon?
So you just believe it without evidence? I thought you said you cared about the evidence.
Well, I have evidence for Jesus, but it's.
But you don't have evidence for the Earth being 6,000 years old.
No, but I think.
But you just believe it.
I mean, but when you talk to scientists and they're super shallow and vapid, it's really easy to throw away what they say. And when I listen to Jesus, he's like really smart and caring.
Wait, does Jesus say that the
Earth
Earth is 6,000 years old?
Yeah, there's genealogies right back.
Where does Jesus say this?
In the genealogy of Matthew.
Wait, so Jesus gives the genealogy?
Well, it's in the book of Matthew, but.
So Jesus doesn't say it?
No, I guess Jesus didn't. No.
So then why do you believe it?
Because I find the Bible more compelling than all of your scientific.
So because you like it more? Sounds like.
Yeah, pretty much. Yeah, especially because
sounds like a great way to form beliefs.
What you guys are saying, and it's all just kind of like, okay, cool, you're gonna die. Congratulations, you did it. Woohoo! You're atheist. Yay.
So this was all cope.
You're coping, bro.
Did you just know me?
I mean,
because look, it seems like that you just don't like the fact that, if you believe the scientific consensus, then yeah, death is permanent. That there is not a feature of you that moves on. There's not some feature of you that moves on to the next world or whatever. It sounds like that this is just like mortality cope.
It's definitely part of it, because it's like, if you're so smart, you can't even stop yourself from unaliving. Like, clearly that you're missing a big piece of the puzzle there. Maybe there's something else.
So you think that because scientists can't make you live forever, it all has to be wrong?
No, I don't think it's all wrong. I think
just the stuff that you disagree with.
Repeatable things. I think if you
what's repeatable?
Gravity seems pretty reliable.
What's testable?
That's probably right.
The permanence of death. That's testable.
I mean, according to your inference, yeah, I guess, right? I mean, if you're gonna
have you ever seen someone come back from the dead?
Then you better infer death too, right?
Have you ever seen someone come back from the dead? And I mean like dead,
no.
Not like they were being like resuscitated by a doctor. I mean like dead, like not breathing, no brain function for days.
No, I haven't.
Okay, so you're not justified in believing that that's ever happened?
Not by like a scientific.
By your standard, are you justified in believing that ever happened?
By my standard, yeah.
I think so, dude. Hold on, what's that standard?
My experiences, really. Do you think there's a spiritual world at all? Do you think there's a higher existence, aliens, spirits, anything like that?
No, I don't, and I think we're done. That's a crazy call. That's absolutely going on YouTube. What a wild world we live in. Oh, and the live chat on Discord is popping off, y'all. Somebody tagged me like 12 times. I don't know why. All right, we have some super chats to read, and then we'll move on to the next guest. Way behind. From Soulsicker with the 2 Canuck bucks. Hey Blitz, I hope you're doing well, bud. I am. I'm doing pretty well. From Welcome to the Real with the 5 British pounds. Why did the gas that didn't become the sun coalesce into a disk? Is the sun's gravity not equal in all directions? This is a really good question. Sorry, one sec. Oops. The answer is essentially friction. So angular momentum is conserved, but when things bump into each other, they are, as a result of the conservation of angular momentum, they're more likely to end up going in the same direction. And so they end up all orbiting in the same direction that the sun spins, actually. Because if they were colliding with each other, then they're likely to slow down and either fall in or end up moving in that same direction. From I Am the Big Cheese with the big $20. Thank you so much, I Am the Big Cheese. Some of these weirdos are incredulous that experts exist. They dogmatically hold religion because of irrational fear of having to change their mind and worldview. They fear looking into the abyss. They prefer comfort over truth. That's exactly where we ended up, turns out. From Ralph Perry with the $3. Thank you. Appreciate you. From Garba Gaiman with the 5 Canuck bucks. I lost a lot of faith in science. Good, you shouldn't have any faith in science. That's a good point, actually. I should have said that. $5 from I'm the Big Cheese again. If science can't prove how my existence is significant and has objective meaning, then science is untrustworthy as a path to truth. Caller. Yeah, that sounds like what it was. Like, it seems like he was just wanting science to do something that science doesn't do. We have $5 from Fear's Interaction. It's going to be super awkward if Jordan gets smarter and listens back to his performance here. I think he's probably older than 25. That would be my guess. So he might not, his views might not change. Charlie's Digital Adventure sends $10. Just send in $10. And then he sends another $10, so $20 in total for, I have to tear you guys down before I can build Jesus up because disproving science makes Jesus correct by default. That's a good point. It is the case that, you know, even if all of our conclusions about the scientific process were correct, then, or were false, that does not therefore mean that, you know, that Jesus came back or whatever. We have another super chat from Fear's Interaction. W Blitz for turning a bad faith call into a teaching opportunity. Look, that's what I always try to do. People can get bored of it, but that is what I try to do. Waku with the $2 sends Elon's vendors require AS 9100 ISO 9001 for any work. Oh, that's a good point. I didn't know that, but that's interesting. I think that those are like engineering qualifications. Mr. McTime with the $2, just send in $2. Charlie's Digital Adventure again sends $5. This caller is suffering from epistemological nihilism. Yeah, he absolutely is. But the thing is it's one thing to be a global skeptic epistemologically. It's a whole second thing to then say, but Jesus. It just seems dishonest to me. Then we have from Soulsicker with the 5 Canuck bucks. But Blitz, have you considered? Nuh-uh. I have not. Good point. Jam and Jay sends $2 to ask the question, what does this guest do for a living? Sales, I bet. Honestly, I would not be surprised. Charlie's Digital Adventure, again, thank you so much for being so generous, by the way. All the ladies love Jesus because he promises a second coming. Come on, you can't make me read that. Game Master Flash with the $10 says you deserve a better quality of troll than Jordan Blitz. Look, he wasn't a troll. Insofar as he was genuine in his beliefs, yeah, he wasn't a troll. I'm certain that he actually believes what he was saying. Dapper Dan sends $5. The Bible actually doesn't assert a 6,000-year-old universe. That's a 17th century invention by a bishop named James Ussher. Yeah, right, I agree. Now, you can kind of derive that it's young based off of all of this. You can derive that it's young based off of like the genealogies and things like that. But what you can't do is you can't say that it's exactly 6,000 years old or whatever. That is definitely an assertion from the 17th century. Sean Griffin sends, this guy cries more than my week-old daughter. And Morgumi sends $2 with, that guy was the worst. I agree. Now, look. Oh, we have 2 Cash Apps, and then we'll move on to the next guest. So Shay sends $10 on Cash App. I wish I could highlight it, but I can't. For pain and suffering. And Steven Sellers, this is from... Oh, I read your whole name. I'm so sorry. I'm not going to affiliate your username then. Steven sends $20. Thanks for taking my suggestion. Yeah, so the question about how he gets to the store, that came from... Steven. Anyway, thank you guys all for being very patient. Let's move on to our next guest. Let's talk to Alexander. Alexander, can you hear me?
Yes, Dr.
Great.
Blitz.
Glad to meet you. How old do you think the Earth is?
How old do I think the Earth is?
Mm-hmm.
Yes, it's probably in the billions of years or close to it, hundreds of millions.
Fair enough, Alexander. Thanks for being here. Johnson, how's it going?
Hello,
Johnson?
I want to ask you. Can you hear me? Good.
Yeah, I can hear you.
Can you hear me? Okay. So I want to ask you some questions. I'm not a Christian, but
I have to ask you first. How old do you think the Earth is?
I think the Earth is a couple of millions of years old.
Not thousands, not billions, but millions?
I'm not sure. I don't know what the scientific answer is, but I think it.
So Johnson, the scientific answer is 4.5 billion.
Okay. Well, I would agree with what the experts say.
Okay. Well, thanks for being here, Johnson. Look, it does say Earth isn't 6,000 years old. Join if you disagree. Right? All right. Let's bring on Christie's. Christie's, how's it going?
Hi, can you hear me?
Yeah, I can. How old do you think the Earth is?
If you don't mind, can I answer from my worldview? So I believe in God, and I believe there's a holy scripture from God, the Quran. I just don't believe the church or the Bible are true, and I believe the Quran tells the accurate age of the Earth and the universe.
Okay, how old do you think it is?
4.5 billion, and then the universe is 13.8, and that's
okay.
reflected in the Quran.
Thanks for being here, Christie's. Kelsey, how's it going?
Hi, I'm doing very well. I apologize in advance for my speech impediment. I am autistic, but I had something I wanted to share with you that I thought you would find intriguing.
Before you do that, I have to ask, how old do you think the Earth is?
I believe that the Earth is 4.53 billion years old.
Okay, thanks for being here, Kelsey. Noisette, how's it going?
Good, and you?
I'm doing all right. How old do you think the Earth is?
So, in terms of like I don't believe there's any past or future. It's just like there's not even present. It's like it's just. So I don't think it had a beginning or something.
Noisette, how old are you?
I'm 20.
So you had a beginning, right?
You can have that perception of it.
So you're 20. You're 20 years old.
Sorry.
You're 20 years old, right?
Yeah.
Okay. What does that mean?
Well, that means that in our society we count years, but that doesn't mean that.
Yeah. So I'm asking, in our society, according to the count that we have, the way that we define what a year is, how old is the Earth?
Well, you said it's 6,000 years old. You said that.
Well, I don't think it's 6,000 years old.
Okay, I have no idea how old it is. I just don't believe in like, I don't know, like, I think that's a weird way to put it in some way.
Look, we talk about how old things are all the time.
Yeah, but that's like just one way of seeing it.
Yeah, so I'm asking, how old is the Earth?
Wait, I have to calculate. I don't know.
Okay. Thanks for being here, Noisette. All right, Dot. How's it going?
Wait, can you hear me?
I can hear you.
Okay, beautiful. So actually, I'm just here to tell you that I really appreciate your work. You can remove me as quick as you want. And to everybody who says that,
I'm gonna do it.
Every Christian who says that the Earth.
Nope, I did it. Meek, how's it going?
Oh, drop me. Sorry.
You're good. VVV5. How's it going?
Hey, not too bad, Dr. Blitz. So
Yep.
I have a unique point of view on that.
How old do you think the Earth is?
6,000 years old.
Sorry?
I do believe it's between 6,000 and 10,000 years old.
Sure.
So based off of what I used to be, what's it called? Used to believe in the evolution of the Big Bang Theory and all that stuff.
Mm-hmm.
And honestly, based off of what we were seeing on that, I thought that, hey, what's the creationists' idea? They say that it's about 6,000 years old. So I looked at that. And there's a proof of how that could be. So, like, because most people that say, well, it can't be that old because it has to have, how can stars be millions of light years away? That makes no sense. So the way that you'd look at that is you'd have to go against that portion. Well, scientifically, we know that if you look at the way that the Earth was created in scriptures, that we're purely basing that on that. It basically says that everything was made and everything was created through masses, right? So
through
we know
masses?
that mass.
I don't know what you mean by that.
It says the Earth was created, then stars were created, and all that jazz.
Yeah,
so
sure.
When you have anything that's made within a certain amount of space, can we agree that there's a bunch of gravity that is created in that space?
Where
increases?
there are things, there is gravity. Yes.
Correct. So when we're looking at that, basically, you're looking at the fact that in Isaiah, in the scripture, it says that God stretched out the sky. Well, if you look at that, if you have a big enough gravitational pocket, the Earth could stay young, whilst the universe could be stretched out in the sense of like expanding type thing.
But it's not. That's the problem. It's not, right? Like we know how much, like we know the gravitational well that the Earth, the Sun, the Milky Way galaxy are in. We can characterize these things very well.
Right, but that's based off of the models that we currently have.
The fact that you're basing the idea that time flows differently in gravitational wells than, further away from them, that's based off of our models too. You can't accept the models in one breath and reject them in the other breath. By the way, your microphone is your microphone, does it happen to be like inside of your throat?
Let me check that. Is this better?
Try again.
How about now?
Still not better. Are you using headphones?
Now? I am using headphones.
Can you try stop using headphones?
I can actually. Give me 5 seconds. So I just want to basically what I've been.
He's using a tin can connected to a string.
Basically, yes.
Oh my god, it's so much better. Thank you.
Okay. Yeah, no problem. I just want to make sure that we are able to communicate properly. So I know you're super smart, and I've seen a lot of your stuff, but...
Well, you're too kind.
What I'm looking at is basically that the way that we measure time is completely... I would disagree with the way that we measure time. In the sense...
Maybe I can ask a different question. How many times do you think the Earth has gone around the sun?
About, that's a big number. I can't make the calculation, but I would say no more than 10,000 years.
So you don't think that the Earth has been around the sun more than 10,000 times?
Correct.
Okay. So the way that we measure ages is from the perspective of things on Earth. And a year, as experienced on Earth, is the amount of time it takes for the Earth to go around the sun, right?
Right.
So if we measure something that is older than 10,000 years old on Earth, that means that the Earth must have gone around the sun more times than 10,000 times.
Depends on the measurement.
If we measure something on Earth that is older than 10,000 years, that means that Earth must have been around more than 10,000 years ago, right?
I would agree with that if the measurement is accurate.
Okay.
So are we talking
what kind of
about
measurements do you think are not accurate? Because I can give you a lot of examples, but I have a feeling that you'll reject some of them.
Well, I might agree with some. So what I'm looking at.
Are you familiar with uranium lead dating?
Yes.
Okay. Is that accurate?
I would say that would have to be based off of what I've seen, yes.
Okay, so uranium lead dating leads us to the conclusion that certain stones or crystals called zircons on Earth, which formed on Earth because they're buried deep in the ground,
right?
That those zircons formed more than 4 billion years ago.
Really?
Yeah.
Okay. So, but most of the times when we see in most textbooks, you're not looking at that type of dating. You're looking at it from the carbon.
No. So when we're talking about the age of the Earth, carbon dating is never used.
Really? From every time that I've looked at it, all the information has given carbon dating.
Carbon dating is never used to determine the age of anything older than 50,000 years. Because carbon dating is no longer reliable past the 50,000 year mark. So you have to turn to other methods, and that's what's done.
So you're saying that there's... where would I find this information at that this...
On uranium lead dating? I can give you an example.
Right. Yeah.
Yeah, let me pull up an example really quick. I know I have this somewhere. So this is an example of zircon crystals that they measured to be like 1 billion years old. Not 4.5 billion years old, but it proves the point.
Right, it would prove the point that it's longer than 10,000 years.
Yeah.
I do know about half-life, whatever Jenny's talking about.
Here we go. And let me make this visible here. Oops. I don't know if you can see this.
I can, yeah.
Okay. Tried to make it as big as possible without ruining anything. So this is a paper it's from a while ago. It's from 1982, it's from 1982. And so basically they were just testing a zircon grain. This is one of the zircon crystals that I was laying out. And so they have a whole bunch of different zircon grains here in this table. Zircon or grain by grain analysis, and then they numbered them. And so what they do is they figure out how much lead, the atomic percentage of lead, is in those zircon grains. So it's 5.9% or 16.8% or whatever. Then they can go, for some of these, they can measure the uranium concentrations here and here. So this is the amount of uranium, 766 parts per million. This is the amount of lead, 109 parts per million. And then they can use that ratio. They can use those ratios and other ratios as well to figure out the apparent years. So what they found is from two different measurements. They found that, for example, one grain is, I just want to make sure that this is the one going across. One grain is somewhere between 900 million and just over 1 billion years old. Another grain they found was between 880 million and 1084 million, which is just over 1 billion years old. All of these grains, with the exception of the very last one, is like close to 1 billion years old.
Okay, and then they're looking at the different ratios of the lead to uranium?
Yes.
How can we prove the fact that lead and all that stuff has been the same throughout all those years?
So I thought you said that this would be reliable.
I would say that it would be if we have more than one study that was right now.
Oh yeah, so this has been done like not 1 billion times. This has been done many times. The reason I like this study is because it's old enough. It's about 40 years old. It's old enough that the way that they described things was not very technical. They kind of just had a pretty straightforward chart, pretty straightforward data. Nowadays, it's a lot more sophisticated because we have a lot more sophisticated methods. And so if you go look at modern examples of these kinds of things, it takes a little bit more to understand and it's harder to display in a single like in a live stream.
Yeah, you're fine.
But yeah, you can absolutely, like, this is not just one study. And in fact, to be clear, they examined 10 different zircon crystals. But the point is this kind of uranium lead dating of zircon crystals is the go-to way of determining the age of the Earth. And so you will find hundreds of papers about this.
Okay, so in that case, then I will have to research that a little bit more and get back to you.
Yeah, and so... and that's not the only piece of evidence. There's other kinds of evidence too. For example, you can go look at ice cores in Greenland. So basically just drill a deep tube down into the ice on Greenland.
I'm familiar.
And just pull them up, right? And what you can see is seasonal changes. So temperature fluctuations, atmospheric composition fluctuations are seasonal. So for example, in one study that I was looking at earlier, there is a known seasonal change in the amount of oxygen of a certain isotope that appears in the northern hemisphere on like a seasonal basis. And so what you can do is you can just go look at the oxygen isotopes. It's called oxygen 18. You can go look at how the oxygen isotope concentration fluctuates year over year, and you find that it does that in this case 104,000 times. So
and
they
that
conclude
also
that
explained by different amounts of vegetation on the planet, though.
So this is a particular isotope,
so it's,
and the rate at which it fluctuates. So the way to think about this is roughly that the reason why there's seasonal changes in atmospheric stuff is because most of the atmospheric gradients, like our atmosphere is pretty uniform. However, because it's hotter in the summer in June in the northern hemisphere and it's hotter in the summer in January in the southern hemisphere, you have winds that flow from one place to another, carrying different concentrations of different elements depending on the time of year. For example, if you ever go look at a CO2 chart, like you can measure how much CO2 is in the atmosphere. If you ever look at that as a function of time, what you'll find is that in the northern hemisphere, in the northern hemisphere in like spring, it gets the CO2 drops a lot. And that's because that's when the trees are growing and they're absorbing CO2 from the atmosphere.
So we're measuring, those ice cores would measure the CO2 in the atmosphere.
No, so in this case, they were using a particular isotope of oxygen. I was just giving an example of how you can use the changes in the atmosphere's composition to figure out when seasons change.
So to my limited knowledge, though, that doesn't go billions of years, though.
No, this one goes back. So this particular one, it's fairly recent and it's fairly easy to understand. This one goes back 104,000 years. Definitely more than 10,000, though.
Okay.
And so, like, there's a whole bunch of different ways that we can figure out the ages of things. And often, if we're doing ice cores in Greenland, or if we're doing rocks left behind by a glacier in like Minnesota and Canada, you can figure out how long ago things happened based off of natural processes. And so those will always, not always, some things happen recently, but more often than not, those things extend much, much older than 10,000 years ago, because a lot of things happened in the past. And so it seems like all of the evidence that we have just agrees that, yeah, the Earth is definitely older than 10,000 years.
Okay, so it'd go against what I currently said as far as the dating goes, but most of them are basically saying that it's your ideology, I won't say ideology, but your scientific mind says that it's 4.6 billion, correct?
Yeah, about 4.5 billion, yeah.
Right, which is where most scientists are talking about. But most of our history that we can even date, even with the lead thing, that's a couple of studies that you've basically said, yes, that could point to an older Earth, but it doesn't necessarily mean that it's 4.6 or 4.5 or in the billions of years. Yeah, so the point is that all of the evidence that we have says it's much older than 10,000. Now, if you're asking for what's the method that we use to figure out that it's 4.5 billion years old, it's basically variations of uranium lead dating. There's also potassium argon dating, which is another kind of radiometric dating. There's different kinds of uranium lead dating, basically, like in different samples. There's uranium thorium dating. Basically, it relies on figuring out how long ago a thing started or a thing formed, and then we can use that as a clock to figure out how long it's been going, how long it's been decaying. Half-life of radioactive.
Yeah, and that's because those are like consistently knowable numbers.
Do we know that they stay consistent though?
Yeah, we do.
Okay.
First, we've never measured them to be substantially different. Like they're always within experimental error. Second, we know why they are the way they are. Sorry?
What is the experimental error?
Oh, it's like tiny.
Okay.
It's like you know, I could pull up like the actual like data,
no, you
and
don't need to. You're good.
It's like tiny.
I'll look it up on my own time. I won't waste
But the point is that not only do we have data that the decay rate doesn't change over time, we also have a good kind of like fundamental understanding as to why the decay rates are the way they are. And those just appeal to standard laws of physics. And unless you're going to say that the laws of physics changed, I don't see why the decay rates would change.
That would be stupid to say that the laws of physics changed.
Well, you would think so, but The guy I was talking to last didn't think so.
Well, that's stupid. Anyways, I could say that I could see where maybe some things could have changed, but the laws of physics have, as far as we know it, our understandings of them may be different, but the laws of physics don't change.
Yeah.
Anyways, I think I'm gonna have to do a lot more research on that then, and get back to you on that, because I think your audience is getting a little bit frustrated with me.
Honestly, I actually think that they probably like you, but I will let you go, VV5. So thanks so much for being here.
Hey, thanks, Dr. Blitz. Have a good one.
Take care.
Bye.
All right, let us bring up 201 Mike G. 201. Oh, he's not here yet. 201 Mike G. How's it going?
Hey, just one question.
Before you ask your question, I have to ask my question. How old do you think the Earth is?
About 6,000 years old.
Okay, great. Go ahead, ask your question.
Have you ever heard of or listened to a guy named Dr. Dino?
Have I ever heard or listened to a guy named Dr. what?
Dino.
Denum?
Dino. D-I-N-O.
No, never heard of him. Oh, Dr. Dino. Oh,
Dino.
You mean, yeah. What's his name?
I don't know his real name.
I know his real name. Kent Hovind, that's his name. You're talking about him, right?
Yes.
Yeah, so not only have I listened to him, I've talked to him. I've debated him.
Really?
Yeah. And he was super unprepared. He didn't understand uranium-lead dating at all.
Well, there was a time that I believed that the Earth was very old. And then I started listening to him.
Oh, you shouldn't. You know, he doesn't really have a doctorate, right?
No, I didn't know that.
Yeah, it's fake.
But everything he said was pretty compelling.
It may have sounded compelling. That doesn't make it true.
And he has some evidence of pictures of things that they found that proved it.
Oh, like what?
Like a tree growing through 3 or 4 different levels of, I guess, sediment or whatever, that was supposedly very, very old, but it's the same tree.
Have you talked to a paleontologist, or sorry, paleontologist or a geologist about that?
No.
Why not? Have you looked it up?
I have not. I was just.
So how do you know that he wasn't just like lying and saying that this was impossible when it's not?
Well, I don't.
So why do you believe it?
It sounded very compelling, and I listened to a number of his talks, and it got more.
So it just sounded compelling?
Yes.
But like you don't know if it's true.
No, but I'm leaning that way that it is true.
Why? If you haven't looked into it, you're just believing a guy.
Yes.
Is that a good way to come to true things?
Maybe not the best.
I mean, look, so generally my view is that if you don't know something and somebody tells you something, and let me back up. If you don't know something and somebody tells you something that is like going against everything that you learned in school, it's reasonable to then go look a little bit deeper into it before you just blindly believe it. Because like generally schools are going to teach you true things, or at least things that are approximately true. There's a reason why we have teachers, and it's because it's to make sure that our population is more well informed.
Okay.
So like when Dr. Dino over here, Kent Hovind, when he tells you something like, yeah, this is impossible, and therefore the Earth is 6,000 years old, that should kind of set off alarm bells on you, right? In you.
Well, it kind of did at first, but then the more I listened to him, the more I started.
But if it set off alarm bells in you, why wouldn't you go double check?
I'm not much of a scientist.
You don't have to be a scientist. You don't have to check yourself. What you could do is you could like, I don't know, Google, how do trees become vertical fossils in stone layers? And then basically any answer will probably be correct as long as you don't get it from Answers in Genesis.
Did y'all have a public debate?
It was on his live stream. This was like a year ago.
Mm-hmm.
It was on his live stream.
Really?
Yeah. He joined TikTok like a year ago or so.
You think it was recorded somewhere?
I don't know if it's recorded somewhere. It was on his platform, and so I don't know if he records them. But he only kept me on for like 15 minutes before he booted me.
Ooh, okay.
He wasn't ready. So the if I remember correctly, you know, he had like the text up.
Reward.
Sorry?
I'm sorry. I thought he had a reward that if someone could prove that it was older, that he would give them something, some bonus.
Well,
something.
he might say that he does, but that doesn't mean that he will. So he had this thing up and he said, like, he had a text up or like a sign up on his background or something where it said, think you can prove the Earth is old or something like that? Call in. So I called in and I brought up uranium lead dating. And he proceeded to waffle about for about 5 minutes. I kept pressing him on it. And then he said, well, I don't know anything about that. I'll have to go look into it more. And then he kicked me. That's how the conversation went.
I see.
Yeah.
Okay. Well, I'm just curious as to, because I've listened to you and you make a lot of sense. And so,
well, I'm glad you think so.
Anyway, I just wanted to run that by you if you had heard of him.
Mm-hmm. Yeah, don't call him Dr. Dino. Also, just as an aside, you know that he went to prison for domestic abuse, I think? No. He only got out somewhat recently. Yeah, let me just double check. So, so if you go to his Wikipedia article, there's a whole section on legal issues, and it has like 8 subsections. And yeah, he was arrested 4 years ago for domestic violence, for throwing his wife, his estranged wife, rather. And then he was convicted of domestic violence. He's also done federal mail fraud, and he was held in criminal contempt in 2015. So he's not really a trustworthy guy.
Okay.
So, like, I don't know. Like, there are creationists. If you want to go pay attention to them, pay attention to the ones who have good moral character.
Okay.
Is that fair?
Yes, sir. Absolutely.
All right. Well, Mike, thank you so much for being here.
Yeah, thank you. Bye-bye.
Take care. All right, we don't have a lot of time left, but let's bring on another guest. Oh, is that Riz in the chat or in the guest box?
Oh.
Munana, you said you wanted to come up?
Yeah. Anyways, okay, I'm kind of nervous, I'm sorry. By the way, my accent is very bad, so if I sound like terrible or something, my apologies.
It's fine, but how old do you think the Earth is?
This might be controversial, I'm going to say, but the Earth is as old as the scientists say, but I got...
Okay, thank you for being here. Okay, I think that we have to do it just for the memes. It's Riz Laden. If you guys don't know Riz Laden, he's a character. He's a long time sparring partner, if you will. How's it going, Riz?
Hi, Blitz. Thank you for that accolade that you just gave me. I appreciate it.
You're welcome.
How have you been doing?
I'm doing all right. How many PhDs do you have these days?
167. I'm the leader of your order, so that's
167. Yeah, you definitely got me beat. So you think the Earth is 6,000 years old?
No, I estimate the age of the Earth to be 1 million to 5 million years old.
1 million to 5 million years old. Okay. How do you get to that?
That's based on the age of the human race being around 6,700 years old. And then the alien race that pre-existed us with an average age of 5,000 years, using a mathematical formula of 1,000 generations, I concluded that the age of the Earth is around maybe 5 million years old.
I'm confused. There's aliens now?
Prior to human beings, there was another race.
Are you still Muslim?
Yes, 100%.
Then who are the aliens?
The jinn.
Oh, okay.
You might call them Freemasons if you want.
Wait, Freemasons are like, that's like a club of old men that exists today, are they aliens?
They descend from aliens, yes.
Do they have alien DNA?
Possibly.
Well, I mean, if they descend from aliens, they ought... Wait a minute, hold on. Now I have another question. How did the aliens breed with humans?
They didn't. They
so then how do humans today descend from aliens 6,700 years ago?
No, the humans don't descend from aliens.
You said the Freemasons do. Sorry, well, do you not think that Freemasons are humans?
No.
What do you think they are?
They're alien hybrid of some form, which are able to shapeshift.
So, like, these guys, I don't know if you can see this. These guys are aliens?
Yes. Have you not seen the
Let me just double check.
episode?
Let me just double check. One moment. One sec. Just one. I just have to double check one more. Are these guys aliens?
Remember, it's the 33rd degree ones, the Master Masons, who tend to be.
So are these guys the aliens?
Could possibly be.
How would you tell?
You can't. The only way you can tell is if you get initiated into their order and then you swear blood oath, and then they'll take you out if you reveal the secret.
But these guys aren't even Masons. Why would you think that they're aliens?
Pardon?
These guys aren't even Masons. Why would you think that they're aliens?
I never said that they were aliens.
You said that they could be.
Yeah, I said they could be.
But they're not even aliens. Or they're not even Masons. How could they be aliens then?
Then they're not. There you go. You've answered.
Okay, they're not. Okay, but you can't tell the difference.
No, I can.
But you couldn't tell the difference here. I just showed you.
No,
I thought you could tell the difference.
No, you have to speak to them to be able to know who they are.
And to speak to them.
Anyway, let's go back onto science because I want to cook you.
Yeah,
on
let's
some
do that.
science.
Sure.
Yes. So, are you sure you want to take on the challenge? Because I am the leader of your professorship.
Yes, absolutely. I'm brave enough.
Okay, then that's fine. So, radiometric dating was something that was created by Freemasons in order to buffoon human beings into believing.
Was it? Yeah. Let's Google who created or who first came up with radiometric dating. Okay, so who was the person that you think came up with it?
It was Pythagoras.
Oh, no, it wasn't. Apparently,
it was.
Radiometric dating of minerals was pioneered by Ernest Rutherford and Bertram Boltwood in 1906 and 1907, respectively.
No, that's not correct. It was Pythagoras.
Oh.
He was.
Where's the evidence of this?
There's evidence within the Pythagoras log which shows that he was
the Pythagoras log. What's the Pythagoras log?
Which is a log of all Pythagoras's experiments and.
Is there somewhere I can go to read this log?
Yes.
Where?
In the Freemason library.
Have you been there?
Yes.
Okay, where?
I broke into a Freemason lodge in my city and I stole their books.
Riz, did you just confess to a crime on live?
Yes, I love doing things like that. Yes.
Riz.
I'm only being sarcastic. I didn't really do that.
Okay, so then where can I go read the Pythagoras log?
Well, you can go to the museum in Athens. You'll be able to get
the museum in Athens. And
yes.
On display there, they have a logbook of Pythagoras.
Yes.
What's the museum called?
Have a look. Museum of Athens. Have a look. It's created.
Yeah, let's pull it up. So, it doesn't look like there is something called the Museum of Athens. That's strange. It doesn't seem like such a thing exists.
Okay, just 1 second. I'll get the exact name for you. 1 second.
There's the Acropolis Museum, the National Archaeological Museum. There's the History Museum, Exarchia. There's... I'm sorry, somebody is operating a wind blower right now outside my window? Literally passing by 4 feet from me, I'm sorry. So where is this museum that you say? What's it called?
Just trying to get it for you now, 1 second.
Leaf blower, that's what I mean. Not wind blower. Leaf blower. The Pythagoras Law Museum of Athens, is it that one?
Yeah, sorry, Blitz. I can't find it at the moment. It was shown on my PC a moment ago. It's not showing up anymore. But
wait, you're telling me I can't go read the Pythagoras law book or logbook?
You could.
Where
but
is
let's
it?
get on to radiometric dating. I don't want to talk about.
But you said that Pythagoras invented radiometric dating, but I don't know why I should believe that.
I can tell you the reason why you should, but you don't have to.
Well, what's the reason why I should?
Because he was trying to make a pyramid out of zircon crystals.
No, but why should I believe that he was doing any of this? That he was involved at all?
You don't have to. Well,
no, I mean, like, what's the evidence? Is there evidence or no?
Yes, there is. Do you believe in trigonometry? Yes or no?
I don't know what you mean by believe in trigonometry. I know trigonometry, yeah.
Do you believe that it's correct?
Yes.
Do you believe it
what does that have to do with zircon crystals, though?
Because Pythagoras found them.
Pythagoras found them?
Yes, and then he broke
what?
the zircon crystal apart, and he got shot in the face with some helium, and therefore he found out that helium was contained within zircon crystals, and he made the paper called...
Where's the evidence that any of this happened? Because it sounds like a story that you're telling me.
I'm not telling you a story, I'm telling you the truth. Helium diffusion.
So where can I read about this? Where can I read about him doing this?
Search up on peer-reviewed papers on helium diffusion within radiometric dating.
So I'm aware how helium, helium is a byproduct of uranium decay. I'm asking about the business with Pythagoras.
Yeah, what you're trying to do is go away from the science and go.
I just want you to look. I don't know why you I don't know why you had to tell me that like Pythagoras invented radiometric dating when it's like obviously a lie. I don't.
Well, you wanted to know more about the aliens that existed on this Earth. Pythagoras was one of them.
Right, but what?
There you go.
Where's the evidence that Pythagoras invented radiometric dating?
Well, I've just told you it's in the library. You won't be able to access it.
Okay, so which library?
I told you, in Athens.
Which library in Athens? There's a lot of libraries in Athens.
Blitz, it's a massive, beautiful building, and it's got stone pillars, and it's got like red on the ceiling with stars inside.
Is it the National Library of Greece, maybe? Is it that one?
Okay, I'm going to turn my PC on just to show you the actual location. 1 second.
Actually, why don't we look up what is the oldest holding in the National Library of Greece? Should be easy to find. The oldest holding in the National Library of Greece is a 6th century fragment of the Gospel of Matthew. It sounds like there's nothing that's as old as Pythagoras in the National Library of Greece.
And remember, when you're using AI, it's very much predicated.
No, I'm not using AI. I'm using Wikipedia.
Yes, even if you're using Wikipedia, it's pretty much predicated on what you type in. So type in, what's the oldest Pythagoras information in Greece?
What's the oldest Pythagorean manuscript? Manuscript in Greece.
And then compare it. Hey, I've got the
So the oldest manuscript directly related to Pythagoras is the ancient Greek text by Xenophanes, dating from around the 5th century BC. He's the earliest survivor. Sorry, he's the earliest surviving source to mention Pythagoras, though it is a satire and not a mathematical treatise. In fact, I don't think we have any texts from Pythagoras.
I've got them. I've got the location now. It's called the Academy of Athens. Academy of Athens.
Academy of Athens Holdings. Great. Okay, let's go to the Academy of Athens. You're talking about the modern one, yeah?
Yes.
Okay.
Obviously,
well, let's go to the Academy of Athens website.
Yes. Bring up a picture of it, and then you'll see where the information is.
Yeah, okay. Here's a picture. The Academy of Athens.
There you go. Do you see them two large pillars?
Yeah.
What are they?
They're pillars with lights on top.
No, they're... See, that's what you see. Let me tell you what...
So I'm clicking on library now. Oh, they have a catalog. Great. Let's look at the catalog. They also have a digital library, which is great. Now, the catalog is in Greek.
Blitz, did you turn off
we can put it in English.
You didn't want to reveal to everyone that you're
no, just because I'm like browsing along on my computer and I don't want people to like see like my name and stuff.
No, sorry. I
so look, we're at
so
I'm just gonna look at Pythagoras in the library catalog. I'll show you even. Pythagoras. So here we have, let's sort by date maybe. There should be a way to sort. Popularity, author, track date number, date of invitation. In the past to newer. Okay, let's do that. I think that's just a bad translation. Oh wait, no, that's backwards. We want the other one.
Can you read Greek?
No, I'm going to translate it. Well, okay, so I can, I can read it, I just don't understand it.
Wow, that's good.
So this is not helpful because we're trying to get it to sort by, it says languages, but like it doesn't seem like the languages function actually works. Oh, there we go. Acquisition date. No, we don't want acquisition date. We want publication copyright date, oldest to newest. There we go. So the oldest thing that they have that mentions Pythagoras at all is from 1926. See that?
Is that how Pythagoras was then?
No, they just don't have anything on them that is about Pythagoras. Although we should probably maybe we can look under author, see if Pythagoras wrote anything. Oh, no results found. No results found for Pythagoras as the author. Seems like that Pythagoras didn't write any logs. I don't know if you can see this, but no results found.
Well, can you just show the building Academy of Athens again, just so that I can show you something and show you how you don't see something? Yeah, that picture. So just scroll it. There you go. So you see them two pillars. You see two pillars with lights on top.
Mm-hmm.
Do you see anything Masonic there?
No.
What if I told you those pillars were called Joachim and Boaz? And they represented...
I would say that you're not speaking English.
Well, I'm speaking English. Oh, well, actually, the Hebrew words that I'm speaking, basically, they represent good and bad, the sun and the moon.
So the pillars represent good and bad?
Yes.
Where's the evidence for that?
And when you join those two pillars together and you unify both of those dualities, you get harmony in the middle. You get harmony in the middle, and that's what the Freemasons are hiding.
Riz.
Yes.
Are you trolling me?
Of course not. I promise you. Just search it yourself. Search. I'll type it in the comments for you. Type Boaz.
I'm talking about the pillars. I don't care about Boaz.
Yeah. Type Boaz pillars, and then I guarantee you.
Boaz pillars Athens National Academy, or Athens National Academy, right?
Yeah. But it's not just there. It's all over the world. You'll see these pillars.
So yeah, so there's biblical pillars of Boaz and Yakin.
There you go.
And
See, I wasn't lying.
But that's not in the Academy of Athens.
It is. I've just showed you right.
No, wait a minute. Hold on. So let's look for the Boaz pillars if we can pull up what they look like. So let's say like this is what they look like. It's the first image on Google.
Show. I have to see on the
like
screen.
This.
Yes.
Right. And now let's go compare them to the Academy. Oh, they look different. Oh, they look different. Yes. These are the same. These are bigger on top than on bottom. These are smaller on top than on bottom.
Yes, the original.
Oh, there's like a big square thing down here. There's not like a big square thing down here.
Yes. So Blitz, the original ones were made of bronze.
Oh, these have like these, you know, candelabra things on top. These like curl down on top. They're like not the same pillars.
Okay, what do you see on top of those pillars?
Those are pictures of the globe. At least one of them is.
They both?
No, the other one's like some Greek thing. I don't know what that is. Oh no, I think that's a celestial something.
Yeah, it's the celestial sphere.
Right, but like what does this have to do with the Academy of Athens? Because we've already established that those pillars have nothing to do with the pillars of Boaz or whatever. And also this has absolutely nothing to do with the Pythagorean logs, which is what you were saying that it had to do with. And Pythagoras there's no evidence that Pythagoras ever came up with radiometric dating.
Okay. Well, that would be, I've just proved to you today by looking at two pillars, which you assume were just pillars with lights on top, was something else entirely. By showing you when you delve into the occult knowledge, you learn more. And what I'm saying is your knowledge is based in science, which is just a pseudo front to what real knowledge is.
You got me. You're right. I now think the Earth is 5 million years old because of aliens and Pythagoras discovering radiometric dating. You got me. You got me, Riz. All right. That was Riz Lawden, y'all. So he is a flat earther as well, or at least he used to be. I don't know if he still is. But he's he's quite a character. I've known him for a few years. Anyway, let us. Oh, he says he's not a flat earther anymore. Okay, that's good. Good. Oh yeah, I guess you can't believe in aliens if you're a flat earther. That makes sense. All right, we have some super chats to read. From Chris, saying, please explain your belief in wind blowers. Look, they're leaf blowers, okay? Hi World with the 2 European dollars. I know they're called euros. With the, can you tell the 33rd alien hybrid outside 2B? Outside 2B, shh. Yeah, if only, right? And then from Neurolancer with the 5 Canuck bucks. Keep Riz talking. I need material for my next D&D game. That's absolutely the right spirit. Riz is quite the interesting character. All right, I'm just going to double check, make sure I don't have any cash apps or anything that I'm missing. Yes, we got it, y'all. We got a letter from one of the most lauded mathematicians still alive to write me a letter of recommendation. Let's go. Anyway, all right, no super chats that I missed. So we're going to end the live here. It's about noon o'clock. I have to eat lunch. I have some work to do. So I will see you guys tomorrow for some more debate stuff. Take care, everybody, and make sure to join the Discord, follow both YouTube channels if you haven't already, subscribe. It's at Blitz PhD, and the other one is at Dr. Blitz Debunks. Make sure to join those, and I'll see you guys next time. Take care.